Hello, everyone. Welcome to my YouTube channel, which is youtube.com/MyWebUniversity. Last time I posted video number 1, which is a full course on R programming language for Windows platform. It was a full course part 1 of 2. Today, I'm going to do part 2 of 2, and it is also from 0 to hero. Last time we discussed part 1, which was this one with the thumbnail, which is already posted. I'm going to be discussing part 2 of this video, which is a continuation of that full course, which is R programming on Windows platform, and the title is from 0 to hero. It assumes that you don't know anything about R programming language or any programming language in concept, but it doesn't matter because I'm starting from a very beginning, novice level, and then jump into intermediate, into advanced, and then even expert level on this one session. 2 sessions of this full course. The first session, which was part 1 of 2, is about 2 hours and 31 minutes. Saying that, yeah, I will cover from 0 to hero, and you will be at least intermediate or advanced level by the end of this course, meaning that you have to read all the documentation that I'm showing you, meaning you have to run all the practice examples. I'm covering a lot of different packages, whether it's database, whether it's Excel, whether it's visualization, analysis, everything on the 2 session, and you will be just surprised how much you learn by the end of this course. So I will make you a hero. You're already a hero. If you're not, you will be a hero after this course. Just follow it up and practice it. That's all that matters. Practice makes it perfect. Okay, so let me get started with this session. Last time we talked about the agenda or the topic of the class. So I'm not going to go through each one of those sessions in detail, but I will just recap it, what we had already covered, so you are aware of it. r-project.org is the website that we went, and then we used CRAN page. The CRAN page stands for Comprehensive R Archive Network. So it's a lot of packages, thousands of packages that are extensibility of R programming language. r-project.org is the website, and CRAN is the mirror for the r-project.org website. So we went to a lab activity. I downloaded R in RStudio. R was downloaded from CRAN. RStudio was downloaded from rstudio.com, and the IDE was demonstrated in the last session. I'm going to be covering a lot of it on our studio, as well as Jupyter Lab, and also Visual Studio Code. And so they will be coming. Since I'm covering a lot of it on RStudio, you will be seeing a lot of examples in R scripts, functions, and database, everything that I demo, as well as I do the Visual Studio Code IDE for R language. You just have to install the extension, which I have done already, and I'll show you how to do that one. Then you could just use the Visual Studio Code for R to run your code. As well as for Jupyter Lab, I will show you what dev tools you have to install, and then once you install it, or interpreter will be available in addition to Python, which is the default kernel for Jupyter Lab and Jupyter notebooks. So notebook. So once you install it, you're welcome to use Jupyter Lab, which I'm going to demonstrate that as well for you. And then the next thing is that last time I made another video about how to install MariaDB, and once you install it, how to use it on Windows platform. MariaDB is kind of like a fork of a MySQL database. When MySQL was originally, MySQL was acquired by Sun Microsystem. MySQL was a database open source that was kind of acquired or bought by Sun Microsystem in 2011. Sun Microsystem was bought by Oracle, and Oracle had MySQL, storage tag, Java, and Sun Solaris. All of the software that Sun Microsystem had it become part of the Oracle database. Oracle has its own database, which is for big size databases. For small to medium size, MySQL is really good. And then in addition, there's a lot of other databases, MySQL, MariaDB, Informix, Sybase, Postgres, and Microsoft Access, and so on. But we will be discussing some of these databases in addition to in the install part. I will be also showing you the RMariaDB package, which is a part of the R package for handling MariaDB database. For everything that is related to database, it's very consistent with R interpreter that when they build R from Fortran and C and R internal code itself, the R interpreter supports a lot of packages for extensibility. And the database packages, for example, for MariaDB, they just name it RMariaDB. And the uppercases matter, so the case sensitivity is there. So when you download RMariaDB, you have to type it with R uppercase, Maria M is uppercase, and DB uppercase. That would be the extension. Similarly for RMySQL, for MySQL, SQL stands for a structured query language, or some people, they also call it the standard query language. And last time I mentioned why we call it a structured query language, because it has a structure for data definition language, data control language, data manipulation language. All those inserts select a data you're doing with the data manipulation or a data definition language, creating tables, creating users, and all of that one, defining the tables. There's a structure for it, and data control language, granted to go. So at the same time, this is called standard query language because it is supported, the same SQL is supported on MySQL, on MariaDB, on Informix, Sybase, Postgres, Oracle, Microsoft Access, DB4, DB2, whatever database that you're naming it, the structured query language is there. Aside, and those are all relational databases. Aside from hierarchical database like LDAP, and then NoSQL, which is like MongoDB and other ones. So everything that is with MySQL database, I will be demonstrating for you on our MySQL package. And then the RSQLite, which is a light version of SQL, and then the client, you have to install it, and then once you install it, you can run RSQLite in memory, or you can run it in a flat file, which would be a database file. And then the flat file in this case is a database, not a flat file that is like an Excel or a text file. It is a database, so you can query on it. That's different than just a flat file. It's based on queries of data definition language, data manipulation language, data control language of SQL. And then it's called light because it's a lighter weight version. It is smaller, and then a giant database like Oracle, or an intermediate side like for SQL Server or MySQL or MariaDB. So we are also going to be talking about introduction to R Markdown. Markdown is very nice for report generation and writing R scripts to just generate some sort of report for whatever reason that you're doing it. So the extension of the file is .rmd, which is R for R and MD for Markdown. And then the package that you're using it to do it is called K and knitr. And then that package is once installed, then it allows you to just save a .rmd file and run it through a Markdown set of instructions or the guidelines or kind of macros that you could just run it and then just create your pandoc. And this pandoc, the documentation also is part of the packages and of R. So this pandoc is also a special purpose kind of report generation packages that will generate either a PDF file. By default, it creates a HTML file. And then you can also install additional packages that could make it PDF or HTML or words and documents. So by default, as I should say, is HTML. And we talked about already what is R programming language. Basically, R is a statistical programming language, and then we mentioned that the time, the year, everything. So you just have to look at that information. At the same time, R is supported on Unix platform, which is Mac OS X, and then Solaris is also Unix, and then there's a lot of HPUX and other ones are Unix related, the concept one. But Unix is kind of like almost in terms of like end of life. It's not end of life, but some companies, they don't use Unix as much as Linux. Everybody is using Linux or Windows or Mac. Linux is, Unix, Mac is OS X Darwin BSD version, Berkeley Software Distribution. Berkeley Software Distribution was the Berkeley software of Unix, which was done at the University of Berkeley, and then based on FreeBSD and BSD. Sun Solaris also borrowed BSD, and they call it Sun OS, and then they build on it, and then they call it Solaris. And then Mac OS X, they used it, BSD, borrowed it, they call it OS X, and then Darwin is the name there, Mac OS X. But Linux, you have a lot of flavors, which is Linux Fedora distribution, Red Hat is also Fedora distribution, CentOS is a Fedora distribution, Rocky is a Fedora distribution. There's also Linux Ubuntu, which is Debian distribution, Linux Mint, which is Debian distribution, OpenSUSE, and many other ones. I'm not going to go through each one of them, but we don't need to. And you just look at the CRAN pages. There's support for Ubuntu, for Red Hat, for Rocky. I already installed it on Rocky, and I could do it for every one of them by just installing the packages correctly. And for Windows operating system, it is provided as well. On Windows, the version that I'm using is Windows 11, and I'm just showing you this video on Windows 11. And this R session is on Windows 11, as I mentioned. We went through our version and system information. R.version will give you the information, and then there's all these details with the $ names and everything. Our base packages, we went through the base packages last time. Base packages have a lot of a core part of the R language. So everything that you want to do is comes out in the package base, and then those functions are available for you. We went through that one as well, and I'm going to demonstrate more. Our CRAN packages, there's thousands of it, and then we went through some of them, and we will be covering more today. Our documentation, we went and show you our help, how to get the help version, and how to get with question mark, name of the function, or library, and help with equal sign, the package name, or help with the function name, or question name, question mark, and the syntax, or show doc, and then just get the documentation. We went through a lot of those ones, so watch the first video. You will be learning a lot. We also talked about R data types and data structures. On the R data types, I was covering R data types: numeric, integer, double, logical, complex, character. I'm going to just pick up on that again today, and over part of the discussion today. So I'll recap these data types as well as the data structures. The data structure that I will be discussing after our data types is a vector, arrays, matrix, list, data, frames. And data frame is one data structure, factor, tibble, and attributes. Attributes is basically object and classes. I'm going to discuss that as well. Our base package function. So when we talk about packages, the base package is the core part. You have to know it. The stat package is also the part of the standard, so you have to know that one. There's a lot of utilities and other ones. File system, we did demo a lot of it, and I'm going to just demo some more if there's need for it as we go through it. File system is very, very important because you have to know how to open a file, how to write to a file, how to read it, how to just update it, how to get information, properties, attributes of everything that you're writing into a handle. That file handle is just updating a file. So with our language, you are having a package called file system. We went through that one, and I will go more to it. Our data sets and data manipulation. The dplyr package is very, very helpful. It comes part of the tidyverse package, which is a collection of packages, and dplyr is one of the package that is allow you data manipulation. Data manipulation and data visualization is one of the features of our programming language, in addition to statistic software, and then very, very efficient in terms of doing everything that S language did, plus some data analysis, data visualization, data rendering, data manipulation, and all of that. So there are some packages that I list here: base, stats, file system, utils, dplyr, graphics, and tidyverse, and more. Like one of the function and the utils packages, find. Find, I showed you how to look for a particular function, and if you don't know which function is the one that you're using, what package you supposed to have. Like for example, on the dplyr package, there's a function called a glimpse by default, because unless you load the library called dplyr using library dplyr or required dplyr, you will not have the glimpse function available. But you have the str, which is a structure of the function structure, which is part of the base, or one of them it is there. So you can use the structure, but the structure is a little bit kind of like too verbose. However, dplyr is much neater. Dplyr package like glimpse or summary and other ones. So we will show you those ones as well. Tidyverse has a collection of packages. Dplyr is one of them, like ggplot2, graphics, and other ones. And there's a lot of packages that we could talk. And the data set is very, very good, efficient in terms of data sets, which are a kind of collection of data that is already available for manipulation and data analysis, and then data scientists and anybody that codes or run some sort of data analysis on the big data. You are looking at data sets, and then from data sets you can create data frames, you can create metrics, you can create tables, you can create a number of other objects, and with those objects you can manipulate it with data analysis and data visualization, plotting them, and so on. So I want to thank you for watching the video. I'm not done yet. I'm just going to ask you to please subscribe to my channel if you haven't subscribed yet, and to watch more videos like this. I have a lot of videos, and then you're welcome to subscribe. In addition to subscribing, please share it with your friends and families and loved ones, because subscription on YouTube is free, right? So everything is free. You are watching it on free. We used to not have even books, or forget about having a video available on YouTube or something. There was no kind of information, but nowadays everything is at your fingertips, right? You just click on some place, you watch a video, and you relax at some place and you watch it and you learn it. in order to just support your community, if you share the knowledge or by teaching somebody that is less kind of an expert than you are, maybe you could help somebody else. And then, believe it or not, when you share this kind of information, you care. By sharing, you are going to make everybody happy, and then just do that one. And then someday they're gonna thank you for it. So, and this is my web university, my YouTube channel, my website, which is I have my web university, and on the left you see my YouTube channel in English, and then on the right my YouTube channel in Farsi. So you are welcome to watch any of them. By clicking one, you will go to youtube.com at my web university, and notice this is the video that I posted last time, video 1 of 2. But I have more than about 1.4K videos. And then the subscription is also growing, but for that many videos and all the topics that I'm covering, and thousands of great videos with a lot of technical stuff that everybody thanks for it. And then when they watch it, as long as you share it and people know it, this subscription is going to go to hundreds of thousands someday, and then maybe millions. Like, there's a lot of website that has millions of subscribers, and then I'm just like making these videos to help people. I honestly don't worry about how many people are going to just watch it and other ones. But what I worry is that if I make this video and then it's like 2 hours and 30 minutes and a lot of technical stuff that could help somebody, and I don't see anybody clicking on it or sharing it, then I feel like, well, I wasted my time. I could have spent that time at a soccer field, or go for a walk, or just stay and relax. But if I just see that somebody shared it, like last time I saw people are sharing these videos that I'm doing it, and I really appreciate it. And some people are watching it, make nice comments. So what is that? Why that matters? It was because life goes on and everybody is just contributing, and then your contribution may just change somebody else's life somewhere in the entire globe, and you never know. And that person may just like a binary tree help somebody else. So I imagine that I'm making these computer science kind of related topics that I taught at the university level, whether it was Pasadena City College, or National University, or Cal State Fullerton. I taught a lot of courses part-time, whether it was computer science related courses or information science. Basically, I've taught operating system, database, C, MySQL, Oracle, and then Windows NT, Microsoft Access, Visual Basic, Python, C++, and then Bash scripting, Unix scripting. And that's why I'm making some of these videos for you, that you could just do it and then learn it, and watch from it and learn from it. Some of the video, honestly, is a lot more. If you just go under popular, for example, and then look at this video that is about 1.3K, so for 13,000 actually 13,000 views, this video is going to go viral someday, because it has 4 hours and some things, and I have like 330 subscribers only for it at this time, and then more than 300 people liked it. So and make some nice comments. At the same time, this video is all about system administration and the highest level that you can just get into, the level that you can help others, mentor others. It's not like a 4 hours of you will learn a lot of Red Hat. And this Enterprise Linux 9 is the latest version of Red Hat. A lot of production companies, a lot of the companies that are on Red Hat, they're on Red Hat 8.10. but this is 9.2, and then I have done it. Similarly for Rocky Linux is 9, and this one is a lot of nice stuff with Rocky. And on top of this one or this one, I show you how to do Red Hat or Rocky, Fedora, whatever. At the same time, I show you administration level. At the same time, I show you how to do application, like how to install Tmag stuff, how to install let's say um, C++, compiler, GCC, and then Python, and how to code in Python, how to run those ones inside here. At the same time, this share PDF files, there's also documentation that I have that I wrote the thousands of PDF file documentation that you could enjoy and learn. You don't need to buy books. So just visit MyWebUniversity.com here. Let me just show you on MyWebUniversity.com. If I go back here, this other one is I'm sorry, this one is for C, my YouTube channel in Persian, or for C, Dari, we call it, because I was born in Kabul, Afghanistan, and until 19 years old, I was in Kabul, Afghanistan. So I left at the time of Russian war, back in 84 year. So I came in, and luckily I survived, and then I made it through United States, and then God bless my brother, Dr. Haman Lutfy. He sponsored us, and then we come in, and then he took care of us until I graduated from college, and he was basically the noble man, and that helped all of us, including myself, and I owe my life to him. But what is important is that God was always on our side, and God helped me succeed, even though the Russian communist government at the time did not allow us to go to college. And then I finished high school in Afghanistan, in Abibia High School. Then I came to Pakistan. 2.5 years I was stuck in Pakistan till we came into the United States, New York. And then before I came to to New York, we were just living in Pakistan, and my brother was the only one that was sending money to Pakistan to us to survive. There was no job, nothing. We were just going to English courses, taking ESL, English as a second language, and then playing soccer at the same time. While we were accepted in the United States, I came in New York. I started at City College of New York. City of College of New York, I studied computer science. Both my brother Hamidullah is a very, very great soccer player, as well as great C programmer, C++, Go language. He worked for Google, for Apple, for a lot of prestige companies. So he is a software engineer as well. We both graduated from Cal State Fullerton. We originally started at Cal State, New York, City College of New York, and then we transferred because my brother, Dr. Haman Lutfi, moved into California. We moved with him, and then we came in all together. God bless, my mom was alive, and then she helped us big time. And then my other brother that is now professor of pharmacology, Dr. Kabirullah Lutfi, he was graduating from Afghanistan from pharmacology. But again, the Russian government, while he was a professor, did not allow him to continue teaching. So we all had to leave. And then when he came in, he finished his master's degree in St. John University in New York. Then he finished his PhD in UCLA. And then from there, we all come in. So it's a long story that we all survived, and we went through hardship, and we did a lot of work. But thank God, God helped us. And then now we're here to serve you. Let me just go back to my website here, the one that I opened. Great. Sorry, let me just go back here. So my web university. I'm going to go back to my website here because I was going to show you documentation. So if you go to one of these two, it's going to take you to this channel. But if you come in here, say table of contents, notice that you have a lot of my book called The Direct Path to Linux Ubuntu. I teach you Linux, the entire Linux online, everything. You don't need to install any Linux operating system or any Docker or any virtual machine or any Amazon Web Services, anything. You just come in and practice it online on my site. And last time I showed you on chapter 2, you can learn everything basic, chapter 3 intermediate, chapter 4 advanced. For example, if you're a very beginner, you should go chapter 2. You could see that's a table of contents here, the list of commands that you can do. For example, if you're looking like what calendar does, you click on calendar and then I give you what is a calendar. Calendar display a calendar, right? Calendar display a calendar. And then the examples, I show you some of the examples and then manual pages for it. So if you say run the cal command, it's going to run the current calendar dynamically on my site, and then it's going to generate the output here. And then if you say, give me the 9070 calendar, it will run the 9070. So everything is dynamic, it's not static. At the same time, if you say, give me manual pages, I give you manual pages of that calendar right here on a HTML format. You can just read it there. And if you say, well, that's great, can I run another command and get the manual pages? Yes. Any command that you know, like let's say, you know, uname, just type in, sorry, I mistyped uname. If you don't type the right command here, that would come out like that. But if you type in like, let's say pwd, and there's a pwd command, obviously it will show. So that's chapter 2. And if you come in on chapter 2, any of these ones you practice, it's great. You can do it. At the same time, this is my brother, Dr. Haman Lutfy, which is kind of like a role model for me. God bless him. 2021, he passed away, and he's in best place in heaven. So the video that I have here is like a list of them, and then you can watch these videos. For all of this, chapter 2, for each one of them, I have a video that here you can watch it, and you can watch it in English or you can watch it in Farsi. And the video, I made it and posted here for you. So if you were saying that, well, that's great, how about chapter 3? Chapter 3, for example, in addition to running these commands, like for example, if you want to run the df command, for example, and say what is df-hf extension for, this says minus human readable, f is file system, and then extended for, and then this is the extended for file system is showing and human readable and size of h for gigabyte or the other ones. So like right here, if you say change group, you can see the documentation here, because I'm not going to allow certain permissions and you can just do it. Change ownership, you can just read it. Notice that a lot of these documentation, like change mode, I present you that umask and all the nice tables. You can do the read, write, execute, all this permission, what is the umask and how you convert it and the permissions. All of that details are here. So you can, you're welcome to read it and understand it and practice it. At the same time, if you're just looking for additional documentation, right here, if you come in on the Linux documentation, I have 32,000 PDF files for you. And this is one Python program that I wrote, whether it was on a Red Hat Enterprise Linux, there's about 12,747 text-based documentation. We call it manual pages of Red Hat from section 1 through section 9. I just generate all of that one in PDF file for you here in a very nice table. So you can just click randomly on any command like ELF executable link format. I just clicked on it. You can see that you can tell that I memorized so many of these ones already. So it doesn't matter which one you click, and then you can see the ISO image. That's another command, any command that you do. And then you could also search for command, like do Control F and say, let me search for Python. So Python 3.pdf, it's there. And then this is very nice because you can see here anything with related Python. And then if you say, well, that's great, can I just go to docs.python.org? You can do Control here, Control F, and say HTTPS. And if there's a link here, you can see that takes you to python.org. So code reusability. This was already on the manual pages. When I wrote the program, I just had in mind that, well, some of these URLs are going to be reference for people to go to additional documentation. So my code just automatically put this URL in a click of a button. Now you're on python.org website. And then if you just want to go to docs right here, all thousands of documentation is there. So similarly, if you just come back here and say, well, that's great, can I do the same thing for Go language? You could type in FMT, and then actually this is not if Go. This is inside Rocky. So let me just show you another way you can do that one inside of that one. But then here we have Linux Rocky version about 11,498 pages. So you're welcome to just click here and then just read Rocky documentation here on PDF format. Thousands of documentation, 11,498. Similarly for the Ubuntu, for example, about close to 7,000, 6,992. And then when you do this one, you click on any of them, you could just click there and you get the documentation. I give full credit to MyWebUniversity, which is my website, which I wrote this PDF program that generated the PDF file in Python, and I used free PDF library of Python, which is Python website, also python.org, and I used in this case the manual pages for Ubuntu. So all these four companies are together. I made it possible to do this together. And then I also post things on my website, which I built it from scratch on the Linux platform and made it secure and everything. And then now you're watching it on that one. This was available online for you at your fingertips. So then at the same time, if you say, what about Windows? Yeah, I have about 1,700 PowerShell commands. So if you say, give me the Control F, you say get dash process, then it will give you the get dash process documentation. So right here, you just click on it, and you get that get dash process. And notice that this case, I give credit to MyWebUniversity, Python, free PDF, but instead of Ubuntu, I give credit to PowerShell because this is for PowerShell stuff. And then similarly, you can just go to Windows, and I will open up a command in PDF, for example, how to make a directory in PDF. So if you're on a Windows platform, you can say help CMD or help make dir. It will run this command, and I just made it available for you. You don't have to be sitting in front of a Windows machine. So you could just see it. And in addition, you could also run this one, and I just have the text to read information here. If I make this information a little bit bigger, you can see this information here. So all you have to do is just click here. It will read this information for you. So let me read this portion of it up to right here, and then we stop after that.
Creates a directory, mkdir, drive, pathmd, drive, path if command extensions are enabled. Mkdir changes as follows.
So if I just continue, it will just keep reading.
Mkdir creates any intermediate directories in the path. If needed, for example, assume a does not exist, then mkdir a b.
So let me stop it. And you could do this one for all these EDA commands and just learn it and study it and practice it and do it the same thing. So this is just one. But if you go on the website, as I told you on my web university, I have the entire book here in 14 chapters. One of the chapters called the Dynamic Generation of Linux Ubuntu Manual Pages. So here you can type in something like I told you, FMT for a Go language, right? Format. So this, when you do this one, you notice that you have everything here. And then at the same time, if you want to go to GNU.org for license of general public license, you can go here, or go to GNU.org, software core utilities, any of them, GNU.org. So all of that documentation, and that you could go back and forth between them, you could and just click on it and study and read it and do that one. Similarly for right here, if you do for, let's say, Java, if you're looking for Java, and then obviously this is the documentation for Java, but I could say Control F HTTPS, and then you could see that open.jdk is the one of them. For OpenJDK, you can see that .org is there. You can go to oracle.docs and then you can search for it. Most likely there is a link here. If I just make this here and say Control F, let's search for Oracle. Right here, docs.oracle, Java, everything. There's so many of them, right? So you could just search for it, and we're at docs.oracle.com. And then similarly, I showed you already Python. Let's say for Node.js, if you look for this one, node.pdf, you can see the documentation is already there. And this is nice because I already am there. I don't have to do Control F to go to nodejs.org, and it's going to take me there. And if I just am interested to learn, let's say under the docs, any of these packages that are there, I could come in and then click on it, and then let's say I'm interested on the OS package. A lot of these ones are there, OS.architecture, and then the syntax, everything is already given to you. It's like much easier than searching on so many places, all integrated in one place that you can come in and find them. Similar to ChatGPT, similar to Google, but there's some beauty on this one, because you could search for anything you like, and then you are already into, let's say I'm looking for R language, R.pdf, I go here, and then I go to one of the reference, in addition to do that one says bugs.r.project, and now I'm on the bugs.r-project. I could say, well, I'm not interested to report the bug, but I could go to or the because when you see a cname dot host name, usually that is a canonical name or alias name, like bugs.r.project. So there's a r-project website itself. So you can go to there, and then you can just go to CRAN, or you can just go here on the documentation for manual pages or frequently asked question, and there's so many of them. So last time I showed you this, maybe you could just look at something else like R installation and documentation. You could look at PDF version, or if you're interested to see the HTML version, the same thing is an HTML version. Okay, so there's a lot to learn here for the documentation. Just coming into my website, you find everything. Okay, that's one thing about my website. That's why I was saying that if you subscribe, you can share it with your friends and loved ones. You don't need to buy books. Sorry, it was a little bit too much on to digress, but it is going to help you. My videos are not here to just create video for no reason. I'm there to just create a video to help you out. Okay, so I'm gonna go to a structure of R, the video that we talked about it last time, And I believe last time we discussed on the first video was our show doc, and we already did that one. And then our show doc was the one that we demonstrate, and we were talking about our data types. So the data types, usually you have numeric data types, integers, double, logical, and then complex and character. These 6 data types are for 6 different data structures that we have. So I'm going to be showing you those data structures, but let's discuss what are the data structure. So one of the data structure that I will be discussing is basically as a vector array. Let me see if there's a list here. I might have already posted it here, but I'm going to just tell you it's a vector array, matrix, data frames, and then list, and then tables, and did I miss any of them? Let me just see. Right here, matrix, list, yeah. So here's the data structure. Vector, we already talked about it. Arrays, matrix, a list, data frames, factor. Factor is the one that I did not mention. Attributes as object and class, and tables. So these are the ones are there, but each one of these ones, when you create a vector could be a vector of text, which is character, or a vector of integers, or a vector of double, or a vector of Boolean, logical, any of those data types, right? And then similarly, an array could be one homogeneous data type. Once you define it, you tell it that whether it's an integer or a character or logical or whatever you define in the array, that is the data type. It's a kind of sequential homogeneous data type. Similarly, matrix is two-dimensional. Array could also be two-dimensional, depending on the dimension of it, but usually it's array is linear, and matrix or called, and then in C and C++, arrays are either one dimension or two dimension. Two dimension is also, you could call it a vector. But then in our language, you have vector, array, and matrix. They all could have different kind of not different different data types, but at the same time they're homogeneous kind of data types when you create it. A list, on the other hand, is heterogeneous. You could have a list that has as elements a vector, an array, a matrix, a data frame, a factor. It could be a table, a list itself. So a list could have a number of them, and then it could be heterogeneous data type, and they're not, it doesn't have to be the same data type. And data frames are similar to what a list is, but the data frame is a smaller subset of data sets. So a data frame is, in some languages, we call it a table. But a table is most MySQL and Oracle and then SQL and other ones, they're called a structured query language tables, which are in the form of a table. But then in a data frame could be converted to a table that has more kind of attributes and details into it that you can retrieve from it. It's much easier with some packages like dplyr and other ones that you can convert it and read it as tables. And then attributes obviously is on the tables, as well as some data frames, some objects that has attributes. Objects could have, classes could have object as instance of it, and each object is representative of that class. Class is a blueprint of it, and then our language supports both functional programming as well as some sort of class-based or object-based programming, which we discussed or will be discussing. So I'm going to come back to the data type here now and demo some of the data types. So right here, we say that data types are numeric, integers, double, logical, complex, and characters. In R, everything is a vector almost. Everything you declare, you say 1 to 10. If you just write this one, it says, give me a number between 1 to 10. And if I just run that one, let me clear the screen here and say run that one. The one that is there, I say run. You'll see that it writes 1 to 10. So this one, as soon as you change the number 1 to 100, obviously it's going to just give you between 1 to 100. And if you say, give me 1 to, let's say, 5 or 15, it will give you 1 to 15, right? So let's just run it between that. But at this time, I'm going to just convert this one back to 10. And this one, you can write it between the parentheses, it will do the same thing. Yet, when you do this one, you're saying that, okay, now maybe I'm going to pass it to a function to determine the type of it. If I just didn't do the type of or class of or some other factorial of it, then I don't need to just put it in parentheses. So now if I just run this one, you can see it says it's an integer. And then if I say, okay, great, that's integer, what is class of it? It says also integer. And then I say, is that a vector? And says, yes, true. So since it's a vector, if I just say is dot integer 1 to 10, right? So right here, this one is also going to say true integer. These numbers are integer. And or you can also define integer as with uppercase L, like that. It also says true is integer. So these are the data type. Like here, I did already another example. So yeah, but I did as integer. That's making sense. So here, I'm going to run this one, say this one is typeof, and it tells me the integer. So let's clear the screen, and then right here, where we are on the class, when we run that one, it says integer. And now our double, this is comment, right? So if I just do this one, it does not do anything. It just says, I run this comment and it did not generate any output. It is ignored by interpreter, but X assigned the value of 2.5 as double, that is a double. So now if I say run the type of it, it says double. Class of it is also says numeric. So that tells me that it's numeric. Now, this one is a vector of logicals. So if I say this one is a double, but what is that a vector? It should say yes, because I said everything is a vector, right? So if I just run this one, say, is that a vector? And it says yes, true. At the same time, let me just clear the screen. I'm right here. You can see it runs this one. And then the second assignment is L1 is logical 1. So you can use the C for combine or collection. And this is true, false, true, false, true, false, true, false. And you can write it as lowercase, uppercase, one character T or F, or just everything in uppercase, and like that, true and false. So that's how you do it. When you do it with the C function, and this is C as itself, if I just run a C, and it says that C is a primitive function. And if I say find within the code C, then it says that C is part of the base function. So then I could say base colon C would also run the same thing there. Let me just clear the screen here. So I meant to say C here, and it will just do the same thing as I just tried it. Because the package as base is already loaded when you install, when you start RStudio. I don't need to type in base colon. I could just write C and it will just tell me the same thing. And then now if I want to create a C of A with comma, let's say B, those two characters, then I say that, okay, that's that. If I want to see the type of them, then I say type of, and then do this. Let me move this one out of this way. Okay, so you can see that this is typeof, and now I need another bracket for that, parenthesis for that, and it says it's a character. But if I say, is that a vector? Saying that that's defined as vector, then I say is dot vector, and then if it is true, because it's a character, it is going to say true. But if I say is that character, and then it says yes, it is also character, both of them, right? And then, but if I say is that double, it's going to say no, it's false, right? It is not double. And same thing if I say is that a factor, and then it's going to just say false. And then is that an array? False. So everything that you just could use it is that a list. Let's do list. Because we didn't define it as a list, it is going to say false, right? So a lot of these stuff. Let me just clear it again. We're back in here. And we did the true false. Now I'm going to say type of it, and then just say logical, and then class of it is logical. L1 through 4 to this. So now what this mean is say from 4 to 8, meaning that this is index 1, this is index 2, index 3, index 4, and then 1, 2, 3, 4, and then 5, 6, 7, 8. So 4 to 8, if I print it, it's going to just give me the false through all the way 5 of them. If I want to just go in the last two, obviously I could say 6 to 6, 7, 8. That's the last 3. So including the one that are there, right? So you can also get the minus, say minus 3, let's say, and then just don't list the third one. And if you just say don't list the 1 through third one. Let's see. Yeah, this one will not give you a syntax like this, but -3, -1, and -3. So if you want to do a combination of two of them, you have to do C and then -1, -3. This syntax might work because what you're saying is that give me a list of -1, don't include this one, and -3, don't include this one, but include the rest of them. Let's see if I can get it 6 of them. Yeah, you get 6 of them. So that's how you get that one. If I go -2, I mean, obviously, rather than having so many of them, you could just so many comma, like -3, -5, -4. It doesn't matter. I mean, -3, and then comma -4, comma -5. So if I want to only see 3 of them, maybe I could have a combination of this and just run that one, and then only has 3 of them. So you get the idea of that how you could remove something from the list by the C function. So in this case, I'm creating a complex, right? So if I say is dot vector, I said everything is a vector. As view L1 is a vector, you can see it's going to say true. Right here, S dot vector L1 is true. Similarly, now I'm creating a complex C1. You just run and it is creating that C1, and then class of it is saying that it's complex. And then C1 plus 10, obviously, it adds up the number after you do that addition, and print out C1, it's going to say 10 plus 1i. And then now, if you do multiplication of it, it just says 1 times 5 is 5i. And then if I just say s dot vector, and then C1, and then s dot complex C1. So you can check for the complexity of it, And then notice if I say is dot character, that would be false, right? C1, and then if I say is dot integer, and then C1. So at this time, I'm checking for the first one. This one should say true. It is true, right? Let me just clear the screen and I go back here. Is C1 a vector? Yes, it is. Is C1 a complex? Yes, it is. Is C1 a character? No, false. Is C1 a integer? Okay, so you can also do the as and then also the type to convert it. But there are different data types that you can convert to something, and some of them you cannot. Like integer, you can convert it to double, and then maybe if you have to do double to integer, then you're deprecating or getting the number rounded off. So you have to be careful with how you do it with ceiling and floor of it and there. So R characters, we're demonstrating the R characters here. So obviously the R character, I could just create here something like, for example, let's say I will just do A for a character, and I just say character A, right? And then say type of A and class of A, and then is dot character A. So this is a very simple way of creating one character lowercase a, and then just get the type of it, is character, class of it, is character is true. But at the same time, now if I want to just more than one character, I could say a is now assigned to, let's just do it on the top here. A is rather than one character, we're gonna use a collection, and then we just say A or B, and then also C. So those are three characters that I want to assign to it. Now, if I just say A, is gonna say is a vector of those ones, is a character and a character type, and it's a character. But if is it also a vector? Is vector A? Yes, it is true. That one should also say true. And then if I say, okay, now do another type of this one with similar one, and instead of this kind of syntax, I want to say letter, and then say a 1, 2, 3. So now I did 1, 2, 3, and then if I just say print A, you can see that this time I'm going to have A, B, C because of 1, 2, 3 here. So letters. I missed the object with S. Notice that you have lowercase and uppercase. So lowercase will print you the lowercase characters, and upper would do the uppercase. And then the index, how many from A to Z you want. So this will be just character true, and then vector true, and then the values are ABC. So if I just change this one to uppercase, or just do the 26 up to all the alphabet A through Z. So you can do this one with that, the index. Notice when everything is there, but now you have A through Z. And now if I change this one to uppercase, object letters, it will do the same thing, except it's gonna do it for alphabetical character A through Z in uppercase. Notice here, and then the letters are now A through Z. And then now if I just say print A of 26, so you have access to the 26 letter here, Z. You can also change the vector 26 to say, I want to do it lowercase z. Let's say you just want to assign it to lowercase z, and then just say A of print it out, you will see everything is here, an assignment that we just changed the value of Z from uppercase to lowercase. And now when we print it, you will see everything is uppercase except the last character is Z is lowercase. And then for that letter, it might be not as obvious, but if I say A sub, let's say E, B, C, D, E. Okay, let's say H, I, J. I'm gonna do H. H is, this is one, oh, A is very easy. One is, and then we just say A. You could do it like this, or just say letters sub 1. Or you could assign it that way too. And now if we print this one A, we'll notice that I change only A, and then it's there, and then now I print it there, A is lowercase. If I want to change 1 through 5 of them, the first 5 of them, I could do that too. So you could just, I'm sorry, what did I do? Letter. Let's see what is the message is. Number of item to replace is not multiple of elements. Like, yeah. So in this case, you have to do the same number that you want to change to, 1 through 5, and change it to that. So you cannot just say all 5 of them assigned to A1. That will not work. Now this one works. See that? Now A through 5 is lowercase, everything else is uppercase. So you have control over it. And then similarly, if you want to do something else, assignment to it, you could do that one. And then also coercing is happening on the fly by our language when you write some data. For example, let's say I define something, say, let's say C3. I'm just going to define something C3, and I'm going to say it's a combination of A and then 1, comma 2, comma true, comma false, right? So let's say I just create those ones, and now I say C3 and get the C3, and then also type of C3, and then let's see class of C3. So if I just do this one, you can see if I run this one, it says assign this one. Now notice that they're all converted to character, because character has the higher precedence. Number has higher precedence over logical. Logical has the minimum privilege. So when R does it, automatically convert everything to character because of this character. And then the class is also character. So if I just, let me just go back here and run that one. I'm going to clear my screen. So you can see that this one, and then that one automatically says that it is coerced to character data type because of that. But if I just remove this one and I have only a logical and number, the number, since integer has higher over it, and this C3 will be numbered. So if I just run this one again, it says, okay, you have all as number. Notice that true and false, true is 1 and false is 0. So it did it to that data type of double. And then double has a higher precedence over logical, and the class is numeric. Okay, so coercion happens on the fly by our language. And some programming languages, we call it casting or the data type conversion. Usually a data type is a language is either a strongly type or a weakly type, or not a strongly type. Strongly typed meaning that like C and C++ and Java, at the time when you declare a variable, you tell it the data type. when you declare the data type, like in Python, as soon as you assign a string called x is equal some string, then automatically it says, oh, even though Python is not a strongly typed, at the time you declare the value of it, based on the value, it initializes the variable to that data type. And as soon as you change the x to 5, then it says, oh, now I'm going to convert it. So Python is not strongly typed. Similarly, at R language, it's not a strongly typed. What does that mean, strongly typed versus not a strongly typed? And C, for example, you say int x is equal 5, right? So now you already defined the integer. But, or you could say, char and then character 5. That would be C, C++, Java stuff. But if you say in Python, if you say x is equal Wahid, or name is equal Wahid, doesn't matter, I'm going to call it x, right? So if you say x is equal Wahid, then the data type is a string. If you say x is equal xxx, then it's y, whatever variable you type in, and that's there. So let's say if you say x is equal 5, then it's an integer on Python, based on that one. But you could change that one, say x is equal Wahid here, then you come in and say x is equal, say 55. Now you change the data type. And C, you cannot do that when it says kind of segmentation fault. That is that variable that you declared as integer only accept integer values. Like an array, when you declare it, it's homogeneous data type. Python and other ones, the concept of tuples and the concept of list and other ones, you can see that you have heterogeneous and you can change the data type on the fly. Similarly in R language, let me just show you on R language. So if I say, again, R is also like Python, you can just write this one. That would be the same thing as you're saying x assign the string Wahid. And then also you could say x assign Wahid to the word x. So in Python, assignment works 3 ways. And this is not preferences, because you're redirecting it to the variable x. And this is, and every programming language is supported. But Python, Python, we say Pythonic and then Rtonic. If you say on our way, you have to do it this way. And that is a correct assignment statement and recommended assignment. This one is also correct, this one is also correct, but it's not recommended. So if I just do this, not this, everywhere that I print x, I'm gonna get the same value of it. So if I just come here and say x, and then you could do this one, and then do this one, do this one, and then this one, all of them, they give me Wahid. So whether I print it here saying, let's do this one on one a print statement. Can I just do that one without this assign inside the print statement? Yeah, you could do that too. So you could do many ways in the same variable. But now if I change the last one, and let's just go back here and get rid of these two. And then I'm going to say assign the number 55. Then now print x. And then print class of x. And you could see that this one is printing the string 55. This one is assigning the number 55, and you can see it's class of it is 55. So we talked about that one as well. And now I'm going to jump into the next topic. We covered data structures, array vectors. So I'm going to talk about, we talked about vector. I'm going to talk about the data structure array, matrix, list, data frames, and factors and tables and attributes. So this is one of the examples of program that I did with the data frames. So I'm going to just move this one a little bit bigger up to maybe here, and then just look at this one. So this one just generates a sequential of V2, a vector of V2 that start with 100 and stop at 6,000, increment by 12,100. And then when we print it, this one is like I could just highlight this area and run it. You could see that it is saying the double is that and everything. So type of it is a vector double. And then if I just say, and instead of type of it, I could say, even though it's a sequence of which is a base function of package base, I could say, for example, is.vector, this would also be true if I just run it. Notice it's not true. Okay, so this is how you check on that one. Class V2 is also we already know that this is numeric, and then if we get the value of it, it writes it at that one, or increment by 1200. And now we create a double with the sequential. We're starting with 50 and finish at 500 and increment by 105.10. So now that's also double, and then a class of it. And then I could also say is dot vector and d1, and then also is dot double and d1. So we could just say this should return true. So if I say type of d1 is there, double, numeric is the class, is vector true, is double is also true. D1 is chosen to value double, floating point precision. So create a vector of lowercase letters. We already demonstrate this one, but I'm going to go through that one. So C1, 5 through 9, and it's going to just say those are the one, and those character E through I are the lowercase. Now we're doing the same thing for uppercase, and that's those ones. So I move in a little bit faster on this one because we already did it. With the logicals, we already defined the L1 stuff, so we print it out here. And then array, we're going to do arrays. With the logical, I have more kind of examples I'm going to show you after, but let's jump into array and next. So arrays, array is a data sequential homogeneous data type. So when you declare an array, you could say array, or you could say as.array. And when you check for validation of whether it's an array or not, is.array. And then array makes an array functions by passing the argument v1. Every time you pass in a vector v1 into array, it will just create array a1 or whatever name you give it on this object, AR1, AR2, or whatever. So now we created AR1, AR2, and those vectors, and then on array, you can get the length of array and the size of it, how many elements it has. So each element, you can say array sub 1, it will print out the first array indexes. And array sub n would be printing the index n. And array, you can also get the dimension of it. If it's single dimension, one dimension, it is going to just show you 5 elements. And then if it is 2 dimension, then you could see the dimension there. Arrays like matrix are very similar, but matrix is at least 2 dimensional or 3 dimension or multi-dimension. So you can also do update on element as number 6. Since we declared array 5 of them, in R, you can just extend the array to do that one. Another programming languages are not easy. You have to do it differently by creating vectors and assigning it, or some data structure like a linked list and other ones you can grow and resize it. But here, this one is much easier. You can just and do AR sub 9 and then just give it an array index that will just create it. Now, array 2, when you print it, is 6 elements. And then if I just do length of it, let's say length of it instead of 5 elements that earlier we had. Earlier we are going to have 6 elements. And so now you can see 6. Similarly, if I say the dimension of AR2, we had 5 now, it should say 6. It's actually AR2 dimension is null because dimension of AR1, AR2. Oh, AR1, sorry, we did not have an AR2, the array 2 here. Yeah, 5 and then AR2. Actually, we did have AR2. So let me just see AR2. If I print this one, AR2 is that, and then AR1 dimension was 5, and with the same thing as length. Why AR2 is not showing? Either AR2 is null, maybe because we assigned that value on the first 3 elements. So if we just say as AR3, now if we assign array of AR2, comma 3, this one assigns the first 3 elements of array 2 into this array 3. So now we have array 3 assigned it, and now we print array 3. There's first 3 elements of it, which was these 3. If we want to do 4 of them, then we do 4 here. So as array, that one, you just check it. It says, yes, this is an array. This is like just checking conditions. So I'll go fast on this one, but this one is append. You can write the append function to append to array. So in this case, this one was concatenation. AR4, if you do concatenation, you just get AR4 or the combination AR2 plus AR3. So in some languages like JavaScript or and then maybe not maybe actually is in Java you use the plus symbol to concatenate, and then in Python the print you can also use the plus symbol to concatenate, and this operation overloading we call it, because Python and C++ allows you object-oriented programming with overloading operator. But here we use excuse me, we use C for concatenation of this and that, right? So now we are having this, and then if we say that those 2 are concatenated. At the same time, now AR3 and AR3, 2 of them put together append it twice. So the same value of AR5 is a combination of AR3 and twice. The first one is this one, the second one appended to the same one twice. So then we also talk about matrix. Matrix, you could also have AS.matrix, which is checking for if it is converted to a matrix, or as matrix to check if it is matrix, or create a matrix. This is like a constructor kind of things. Similarly for array, the same thing, lists and the same thing, factor, the same thing. So M3 matrix or 3. So now we have array 3, we're going to create a matrix from it. Let me just clear the screen. I'm gonna move this one and a little bit up. I believe that's good enough right here. So I'm going to just say create a matrix AR3, and you can see that it created. Now type of M3 is that. So if I just do that, class M3 is there, and then as matrix M3, it is matrix, yes. And then is it array? Yes, true. Is it data frame? Says false. And then the actual value of it, because it's a matrix of 1 by 3, 1 column and 3 rows, so it's called 3 by 1, 3 rows and 1 column. So if I say number of rows, it's going to say 3. Number of columns is equal 1, and dimension is 3 by 1. 3 rows in 1 column. So row names, now you can use the same name of the matrix to use the function row names, and then use the variable name of the matrix to just give it a row value. And then you can use the C collection for the row 1, row 2, row 3, because there's 3 rows on it, and there's only 1 column. So when I change the column name, I could just use the column names of M3 and just give it 1 column name. So this is just an assignment. Now we have, when we print it out, it says row 1 through row 3, and then column 1 as a result of these 2 statements above. That's how you assign the value for it. And then M3, now we're creating 3 by 3 of matrix sequential from 10 to 90 with a difference of 10, but 3 rows and 3 columns. So that's why it's called M3 by 3. And now you see the common is a matrix of 3 rows and 3 columns. Let's see if that actually does work the way we want. So now we have this one. Let me clear the screen and run it from here fresh. So you see it is a 3 by 3. And now when we print it, you can see that it is 3 rows and 3 columns. So these are the rows, and each one of them is 1 row, 2nd row, and 3rd row. And this is the 1st column, 2nd column, 3rd column. And then when you do the, is this a matrix? And it's going to say true. Is this a array? It's true. Array and matrix are similar, but matrix is to multiple dimension, 2 or more. And then dimension, if you want to print out the dimension of it, is going to say 3 by 3, because 3 rows by 3 columns. And then number of columns is 3, number of rows is 3. And row names, now this time I'm using apple, pear, orange for it. And then column names is box 1, box 2, box 3. So let's say I create this row names for it, and then column names. And notice that if I just print it, now this cat concatenation fruit with amount of in each box, and this slash new line is going to just print a new line character. So it says error. Let's see why it says error. Unexpected symbol and new line characters. Concatenation fruit. I don't see any reason unless this character with the space is misunderstood yet. So in other programming language, it knows the slash, but here there's need a slash space for it. So if I just do this one and then run this one, that would work. Just be careful if you're having a space here, no space will just generate this error. It did. Earlier it was generating error, but just to be safe side, you could just leave it like that. And then I think if I save it, let me just see if I save it with this and then run it. Yeah, it still works. So all programming language should work without space or on that one, but it doesn't matter. So since it's working, I'm gonna do it. Maybe there was an extra character somewhere that was seen invisible character, we call it. M3 by 3, now if we print that one, so it's gonna say that. Let me just say, okay, M3 by 3, we run that one, and then we say now and apple, and then each box. So apple on box 1 is 10, box 2 is 40, and box 3 is 70. How many orange you have on box 2 is 60. So now if I say, let's say M3 by 3 of, let's say if I want to get the 60 value, that is row 3, column 2. That would give me the 60. And similarly, if I wanted the last one, that would be row 3, column 3. You get the idea that how you print that out on those ones. And if you just omit the column, then it's gonna give you the entire things on row 3. And then I mean column 3. If you want to say omit only the columns, and then give me the last row, which is 30, 60, 90, that would print out those ones, 30, 60, 90. So depending on what you want, right? And that's indices. And there we talked about fruits with the boxes and everything. And then right here, I'm creating a list. To create a list, you can do a list, or you can do as a dot list. And then when you check for validation whether it is a list or not, is dot list. So now we're just saying create lst1, and then assign those vector 1, v1 is a vector, v2 character 1, character 2, metrics, and data frames. Data frame is we haven't talked yet, but on my other video I have talked about it, and I'll talk about it today. So we are creating a list, which is a combination of all these vectors and a data frame. But notice that when I say what is this one, it says it's a list. What type of class is a list? Is data frame? That's true. Is it a list? Is data frame is false actually. But if I say is a list, which was already true. Now, if we want to say give me the list itself, it's going to show all the elements of the list. So the LST1 is pointing to vector 1, and then vector 2 and vector 3 and so on, all of them, including the data frame. So if I just say LST1 sub 6, that would give me this data frame again by printing the last elements of it. If I just say give me the 1 of it, the first one, vector 1, and give me the 2, it is that one. So depending on what you want, and then you can also assign a list right here, say make an assignment statement for list 1. Now list 1 is changed to vector 2 contents. So earlier we did list 1, it was 5, 6, 7, 8, 9. Now it's this list 2 because of this assignment state. That's how you just change that element of a list. V2. So we printed the LST. Now, if I want to print the list element number 5 or number 6 or number 5, but row 1 through 3 with columns all included as default, it's going to give me that. List number 5, 1 and 2, and then I will give you that. So you could just go what the indices, eliminate either the row or give it the columns. Say, give me box 1 and box 2. This is 1 and 2. But I didn't, I said everything. And then on the 5, list 5. So that's how it is. So if I say LST1 sub 5, just to explain that one, you can see that I have more than one more column with box 3. But because this statement says don't give me box 3, only give me box 1 and 2, it will just do first column and second column, and that would do that one. So we did that one, and now you can also create a diagonal of a list. So let's clear this screen. When you do diag 5, notice that it says put 1 on everything diagonally. Everything else is marked with 0. This diag 5. When I see diag 1 to 5, now this time it does the same thing, but the numbers, instead of putting 1s, it puts 1 to 5 because of that. And now if I say diag 3, guess what? It's going to say the 3 elements of 1s, right? So if I just clear the screen here and say run that, 1s and 3 times. If I just change this one, say diag of 1 colon 3, that is going to just say 1, 2, 3 diagonally, like that. So this one is the XC 10, 20, 30 is going to produce you those numbers 10, 20, 30, because we did not want to have this. You can also do sequential of sequence of the elements assigned to it as well, however you want. Data frames is another very good data types that you have kind of rows and columns information. And with data frames, you could do a lot of manipulation with dplyr packages of doing select, filter, and piping, and get more column-wise information. So a data frame is a data structure. And then I'm going to just run this one to just create a data frame. Data.frame, well created as .data frame, is going to also do the same thing as data.frame. And as the .data frame is going to check whether it's a data frame or not. So if I say, for example, is data.frame and df, this one we already run it as clearing the screen, say run this one. We did it now. Type of it says is a list, because a data frame by definition is a list. And then is data.frame is true, and then class of it is a data frame. And when you print it, it's going to print the data frame. So the data frame has 5 rows and 5 columns in this case. And each column has the information. You can print data frame also by using V1, V2 with the dplyr package. So I don't know, I have already have a video on there. I'm going to just show you a quick stuff here, because I don't think on these other examples I have the chance to show that one. So I'm going to say library dplyr, and then don't write the E after YER, otherwise it will not work. So now I'm loading the dplyr package with this right here. You can see it's there. So now if I say, give me a glimpse of glimpse of data frame. This data frame, when you run it, you see that it gives you a kind of information. It says this data frame has 5 rows and 6 columns, and these or the columns V1 through L1, or the actual vectors. And then here, this one is the data types. The V1 is integer, V2 is double, all of that. You could also get the same information from a structure, which is a base package, right? So you could also run this one, it will give you. But notice that structure has this kind of information. So it says a data frame, 5 objects of 6 variables, and then it does give you similar information, but I think dplyr is much easier, because you can see on both of them the data type, and other ones is kind of like a little bit prettier in format with the dplyr glimpse method. You can also do a summary of a data frame to get a summary of it, to see that details of that data frame. So summary V1, V2, D1, and then C1, C2, and then each one of them, the length of it and everything, so you can do that one. But if I say, is summary part of the base or part of the dplyr, you could say find, and then put the word summary here. And then when you just do a find on it, this one is going to say that this is RMySQL and base function. So summary is part of the RMySQL package, also part of the base package. If you need help on this syntax of it, what you want to do is say find, not find. You could say question mark, and then say RMySQL, and then colon, colon, and then say, what was the function summary? So this one will just give you information on the RMySQL. When you run this one, notice that the help shows up on it. No documentation and summary of this one as specified in libraries. You could try summary. So the reason it is there, not there, maybe we did not load it. Maybe it is loaded. But if I just do by itself, like R question mark summary, and then see if it is coming from which one. So now notice that it's coming from the base summary. And then the reason I did and this other one did not work is maybe I could say R MySQL colon, and if this one says you have to do the fuzzy logic of double question mark, I'm not gonna do that one, but I'm gonna say let's load R MySQL database. So you can use the library and then load the R MySQL, or you could just say pound. This is a common, so you could say either one of this one will load that R MySQL. Whether you type in library or require, both of them will do the same thing. So now I'm going to just run this one, and then now library MySQL is loaded. Now if I just run this one and do that one, it still says I don't understand that. But if I say, because it's part of the basic package, so it uses automatically the base package, and you can see here it automatically uses the base package and there. And then if you just want the RMySQL help the library, you could say library, and then you say help is equal, and then you say RMySQL. This one is going to be more informative, because you're saying everything that I need to know about RMySQL package, open it up for me in the help. And now it's going to open the RMySQL. It says, okay, RMySQL is this one. If I just make this screen bigger, you can see that it is more about RMySQL version 0.10.20. Title database interface and MySQL drivers for R, and it tells you all of the details, all of the functions that are within the R language, and all the details here, right? So you could do that one. But if you just need additional help on this one, you could also say, for example, R and then MySQL and then colon, and then notice that as soon as you type in colon, a list of all the package functions and classes and double string and variables and static number variables, everything is there. The methods that are there, the functions, everything that is available for you, it is going to show you. So if I just say summary, notice that here our summary is there. And this one says by default, it says summary object. Summary is a generic function used to produce result, a summarize of the result of this. So if I just do a summary on a data frame as input, what does that do? Let's just find out. And you can see that it is running the R summary of data frame. So if you want to get the R summary of MySQL, this is the syntax that how you pass on to get this summary of that one, because this one is part of the base also. So if you want the base function, you say summary data frame, or you say a base colon summary and then data frame. So since base is already loaded, you can use it right away like this. But if you did not load RMySQL, then you have to do this. When it is having conflict with both of them, then you cannot do that one. Because when you say find this df, this df is used, you can see here, df is used on both of them. As part of the, not the data frame, sorry, summary. So that's stat, df is another part of stat, that's in addition. So I was looking at find this one. So if I just say this one, it says it is on RMySQL and also on base package. So if I just do this one, summary of df, that will give me a summary like that. And then earlier I did my RMySQL. Let me clear this screen and then run the RMySQL first. Look at this syntax here. RMySQL, let's say v1, v2. This is the format that it does. The summary gives you that format, which is similar, very similar. And then the base summary with the base is very similar. So it's not having that much conflicting things. But however, something on the dplyr, for example, filter. Filter, if I just do a find on filter. So filter, if I say find that package, you can see that package is a bit on, sorry, find filter right here. Let me just clear the screen again. So find filter, you can see it has a conflicting on dplyr as well as the stats. So now what does that mean? That when I use the filter method, is it using the dplyr or the stat package? That depends on what you have loaded. If you have not loaded the dplyr package, then obviously it will just use the stat, because the stat package there. But if you want information on help on it, you could say, show me the difference. So say dplyr colon filter. This would give you the dplyr for filter package. If you run this one, you see it's coming filter. I mean the filter function in the dplyr package. But if you run the question mark stats colon filter, now this time we're going to get here the filter function in the stats package. So if I just run that one again and say give me that, now you see filter function in the stat package. And the syntax may be a little bit different, so you have to be very careful to do it differently. Okay, so now since we are on the data frame here, on the data frame we talked about it, I'm going to just data frame, even though I did cover it on another video, I'm going to show you a little bit on that filter function itself with the dplyr. So if I say, give me the data frame right here, notice if I run this one, it's gonna just give me a data frame. Okay. Now if I just say, okay, I got the data frame, but let's do Shift Control M will give me this piping. This says that give me a data frame, but then I want to just do head of first three of them. So this is saying this information, but I want to only get the first three rows. That would be like head 3. This one, if I just run that one, notice that it gave me only 3 rows, right? This one will give me only the first 3 rows. And then now I could further do another Shift Control M that would do another piping. And then I could press enter here. I don't have to type in one line. I could say, what do I want to do? I want to select, say, V1 to maybe C1. So I could say select a V1 through C1, which would be this column, this column, this column, this column, the first 4 columns. So this would be a select statement, which is provided in dplyr, and I'm saying that give me those 3 columns. So if I just run, now it is giving me those columns, right? So right here, This one gave me those 4 columns. Now I could say, okay, how about I could do further another piping. I could say, Control Shift M, and then say another pipe, but this time I'm going to use the filter. I'm going to say filter, and then I want to say where D1 double one is greater than 50 .9, which is not going to include the first row, and less than 260. And then I say and D1 is less than 250. So now all of a sudden I'm just checking for some number that is only giving me this second row, right? So let's see if that one gave me only the second row. Yeah, it gave me all of that. And then you could do further filtering for further piping and everything. But I'll talk about logical condition. This is like a greater sign with the filter. And then on the Oracle and MySQL and Sybase and Formix, Postgres, Ingress, and Formix, Microsoft Access. When you do a structured query language, you have these statement called data manipulation language, select, insert, update. All of those ones are for pulling data and inserting records into the database, updating records, and so on. So this is also a part of the query language that you could query with select and filter and arrange and other ones. So different way of doing it, but our language makes it much easier for data scientists and non-programmers. So you can just pick up the column that you want. It's almost like using an Excel spreadsheet, but at the same time, you have more control with this coding, with piping and other ones. On top of it, the syntax that you do is much easier than writing it in C or C++ or even Python and other ones, or is much more easier in some ways to filter information. And what you want is that's a more English-like instruction that you can put in. If life could be that easy, that everything nowadays is done the way that people do it, is one reason that they did it with assembly language, and then they wanted to see and see programming languages like, okay, these high-level languages like Pascal, C, and Python, and then C++ and other ones. Even C++, for example, the concept of pointers and other ones, a lot of the developers, they had memory leak when they were writing Python program, C++ program. But in terms of memory efficiency and other ones, if you can handle it and you can write code that are efficient, most likely C++ would be the language of choice because it's much faster. But if you want to do it faster than C++, maybe you could write it in native C or assembly language even, because C++ was written in C, and or some of the operating system were written in assembly as device drivers and mostly in C. Even Python and Go language and Swift and maybe a lot of these languages, including R. R was written in C and then C++. I'm sorry, C and then Fortran and then R internal itself. So yeah, those languages sometimes did a lot of the hard part of it, but now the easy part is that how to make it user friendly and easier to use. And then these functionality, you don't have to declare a memory a variable in the memory and then control the heap and then stack and then memory pointers, and none of that one. You could just write the code and pull the data and then work on big set of data and do AI stuff, do data science stuff on the fly. You don't have to be a internal coder of a system, but it helps, okay? So that's all I'm saying is whether you do it on R or Python or another one, there's a lot of nice feature on either one you have to take advantage of it, what benefits you, and just do it in that language. So we did the example here. And factor is similar to enumeration data type in C and C++. So it's for categorization. For example, here we are creating a gender variable with factor of female, male, female, male. And this is a collection. So when I do this one, the gender gets created. And then let me move up here, and then we could see that this one just basically create the gender. And then now is factor is a gender? Yes, that's true. Now, if I printed those one, female, male, female will be printed. And the level, if you didn't assign, whatever is the one that are being used, in this case, female and male, or the two factor levels, it will print it that one by default. But you can, as a developers, you can assign the levels also, which I show you next. And so here you have gender of 3, you could see that it prints a male. The level is the same. Gender of 1 and 4, female and male. Female is 1 is this, and 4 is the last one. And then gender of 1, you want to assign it to male, you can just change it to male, and then you print it out. Now gender of 1 is male from female. So you could do that. Now this time I just create a factor of fruits, and then apple fruit, and then apple, pear, grape, orange, and grape. So fruit is plural for singular, and other ones there's no s, fruit. So here we do fruit, and then we say it's for a factor. Yes, it is true. And then class of it is a factor. And then it's a integer data type because enumeration data type. Fruit is a value of it is those. And notice that the levels is apple, orange, grape, and pear. All those ones are assigned there. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4. One of them is not assigned because for some reason, for the fruit, 1, 2, 3, 4, 5. So as factor and type of it, and when you print fruit, it writes apple, and then pear is the last one. Grape is there. Oh, grape was twice. So if it is twice, only one of them is used on the levels. If it's 10 times, only one of them is used there. So if you have a male, female 100 times, the level would be only a male and female. Similarly for the fruits, since we had grape twice here, only one time it's used here. That's what the levels means. It's a factor of fruit and type of fruit, and we are there. Colors similarly look, and we did red, green, blue, white, black. So those 5 colors or whatever number of, 5 of them. Now, if I print colors, you can see that we have the one that we assign it since we did red, green, blue, white, and black, and then white, black, and green are there, and then red and blue are not applicable because it's not part of the levels. And then since I assigned the levels to be white, black, and green, if I remove the let's say the green color, let's go back here and remove the color, the levels. And since I assigned it, if I just remove the green color, and then for the green, it will say not applicable, and then we'll say the same thing. So now run this one, and then you can see that it's green is also not applicable. The levels is white and black, because whatever you assign the levels, those will be in the category. And then from a data frame, you can also convert it to a table. So now I did this one data frame. Now I'm saying is that table. Let me just clear it. I go here and then say run it. So first we assign a data frame with the constructor Tibble. We created data frame Tibble, and then now we say, is that Tibble? It says true. And then print out the data frame Tibble. Notice that it says 5 by 6, 5 rows and 6 columns, and then all of them, or the data types and columns are shown, and it's a table with a nice kind of format. And then if I just say, give me only column V1, which is this row, and this column, so I could say that one, and it will print 5 through 9. And then if I say, give me D1, D1 is this column, and then $ D1 would give you that. And similarly for all of those one with $ or the column-wise information. So if you want to say the indice of 1 to 2, you could get everything on 1 and 2 column. And then similarly for row 3 and everything, on row 3, you could say this one. And then this is last 5 rows. I mean row 5 only, last one. If you want to print the last row, which is 5, and then data frame table, if you want to just get it, and then this is the last row. Attributes is also similar to objects and classes, and so everything that you can create in these objects, sometimes you could have attributes on it, and based on $V1 and $V2 and other ones, you could pull the information in there. Glimpse and a structure, str, was the command that you could get the definition of those ones. So for example, if I say glimpse of data frame _ TBL, you could run this one, and you see by running this one, you get a structure of it, and I mean a glimpse of it in a very nice way. Each columns that it says row 5 of them, column 6 of them, and then each column is V1 through L1, and then the data types that are there, the number of rows, values are there. Similarly, if you could say structure of it, of data frame on Tibble, you could get a structure which is a base class, base package, like that format. And then we already did the summary also from the base df _ table. And then you could do that one, and then if you want to just get ahead of it, you can say head of data frame _ TBL. Sometimes head, you can just say, give me the whatever number of rows are there. In this case, it is not too many. It will head as a cell gonna give you 5, because by default I think it is 6 of them. But if you want only head 2 of them, you could say give me head 2 of them. If you want 3 of them or 1 of them, whatever number, you just give it this one, head. And notice that the head is also similar to this head. You can also get tail of it. So this one is head of this. I could also say, give me the last 3 from the bottom. So and then instead of head, I could just say type tail, and then that would give me a tail of it. And then you can also view it. And so views, and then I could say data frame _ TBL. And this one is when you view it, and that way it's going to print it out in a view, not the views. And so if you run it like this, and it's going to give you in that format that you want it there, in a very nice, like a spreadsheet kind of view, right? And then if you just double click on this one, it opens up in this format, which is kind of more column-wise everything. And if you could filter it and everything, I'll show you those ones also. So we did talk about it. And then another thing is that data sets. So by default, if you just run the data, this one, if you run this data, let me just take this one out and then run this one, clear that one, and then say So when you run the data, this is just giving you all the data sets that are available in our language by default. Data is going to give you everything, all the data sets that are available here. Like women, and then iris, and carbon dioxide, and then who, health, and empty cars, and so on. All of that one are available. Star Wars, everything, right? So all of those data sets are available for your manipulation. You can also say data sets, and then right here, colon, and let's say you're looking for Star Wars, you could say Star Wars. Let's see if Star Wars, and then you run this one. Let me just see Star Wars. Okay, so it does not show like that, but I could say, let me just load it first. When some of the data sets, if it's not available for you, what you want to do is right here on the statement that I did here with data sets, empty cars, and like, for example, empty cars, I could just say, give me a structure of that one. I'll show you in a second the other one also. Library dplyr. So now I did the dplyr. Now data sets empty cars is getting a glimpse of it. So now let's see if a Star Wars is available, because when we did the dplyr, may load some of the package. Maybe the dplyr does not have it, but the tidyverse has it. So if I say data sets, colon, and notice that the list of the ones that are there is Star Wars. It's not going to show. So what I'm going to do is say library. I'm going to say tidyverse. So now I'm going to load the library tidyverse, and then see if a Star Wars right away shows up. As soon as I do this one, there's a list of packages that are now loaded as a collection of packages, including data sets. So now say Star Wars, notice Star Wars right away, it shows up. So right here, if I say Star Wars, you could see all the Star Wars package here coming in. And if I just say, what is this one? Is that a class of a Star Wars? If I want to say class of it, and then you can see it's a Tibble, and Tibble and data frame. So now if I say give me head of it rather than class, head of it, and then just first number of rows that are there. And then you can see that the first 6 rows are being shown, as I mentioned earlier, 6 by 14. So here, when you do a Star Wars, and then you can also say, if I want to get some of these columns, you can do that one as well. Or you could just say $, for example, name. See, right here, whatever these variables that are there, you can say $, of that one, and say, give me the name only. You can see like that too. And then on this one, you could see whether you want to do this information or some other thing. You can also do with piping, with select and insert and all of that. So if I just don't say the $, and right here, and then say, give me the head here. And then now I have these ones. Notice that and this information name. So I could say do a shift control M, which is filter, and then I say give me a select name, comma, let's say height, comma, air color, or eye color. So those 3 columns, if I want to get that one from the first head of it, I could just run that one and I get that information. And then at the same time, I could filter it further and say Control Shift M, here I could just say where this condition is true, and then say filter name is like I could say like, or name as equal, and then I could say exact word and dart vather, let's say that information. So I want to just pull that information. I could say it unexpected this, because I should have done the Control Shift N here, and I did it instead on the next to the column, so it did not understand it. Now I could do this one and then say run it this time, and it will just do it. And so that's how you do the filter piping. So, and that's the sample piping. So you can see that it's pulling that. Similarly, if you do for iris or in tcars, you just have to load that data sets and pull the information from there. So our base packages, we did show you some of the packages. Let me go back here. Okay, so our base packages has a lot of them. So the way you would know the base package functions, you just say base and tab, and then right here, for example, absolute value of 10 is going to give you that, and then minus 10 is also give you that. So everything that you're looking for, that one, if the base is already loaded, you don't need to put the scope resolution package name information. You could just directly get a use of it. And then the base package, as I mentioned, if you need this, you could double, and then all the functions that are there, thousands of them, are here. You can use, this is the core part of the R language. So you could do everything, whatever. You just type in S for sequential, and then if you're looking for sequence, it's there. If you're looking for seq or seq.int or whatever, you just go in there. Let's say you're looking for find. Find is not on this one, and so it will not. It says find.package, and then there's another find here that is uppercase find. So this is all. So I'm giving you some X variable to find something within that one. So if you say utils colon find, then this one is utils colon find. This one is going to tell you that one. So let's say I say find the find command itself from the base, and we'll say that, oh yeah, find an uppercase is there. Similarly, if you say find the mean, which one is there, it is in the base class. Standard deviation, which one is it in the stat function? Median, where is it used? It's on the stat function. Factorial, where it's used, you could do that one, and you could see that one on the base. So if you say a factorial of 5, it's going to give you 120. Factorial of 1 to 5, it's for the vector of 1 to 5, all of them are there. So if you say factorial of 1 to 10, it will give you this. And then if you say times 2, it just multiply by 2 every number that are there, every element of that thing. And if you say to the power of 2, it will just be the same thing. It's just bigger numbers for those ones. So, and depending on what you are doing, it's like factorial of 5 should be that. So to the power of 2 is 4, and 6 to the power of 2 is 36, and so on. So we get that information. Fine. Okay. So here I'm going to show you the find. Gamma is a very good function that you can get also. Gamma is giving you factorial of the n plus 1. What does that mean? So if I just clear my screen here, if I say factorial of 5, it's going to say 120. But if I say factorial of 5 and gamma if 5 plus 1, that's also 120. Both of them are equal. So this one and this one, this is true, and this one is true. So if I say, is that equal? Obviously, I say I could use the equality symbol, say, are they equal? And then it says yes, true. Because gamma of 5 plus 1 is also going to return 120. So whatever is the n, let's say n is equal to factorial of 2 is equal to, right? Factorial of 2, and gamma of 2 plus 1 is also 2. So whatever those numbers. So if I just say this one is let's say 11, and then this one is 5 plus 1, this is not equal. So it is false. But if this one is 11 plus 1, gamma of it says true. And similarly, if I just do same thing with, let me just clear the screen, go up here. If I just did this one was equal. But what about factorial of 9? Is it that equal? No, it's false. But if I just change 9 plus 1 and the gamma, because gamma function is n plus 1 is going to return the factorial of n, it will be that, the same. Okay, so we did already and do, like, if you do find gamma, this one is in the base function, and then factorial is in the base function. I mean package and not function. The function factorial, the function gamma is on the base function package. So, and this one matrix is also on the base package, and then array is also in the base package. So data.frame, when you search it, and data.frame, it did not find it. But if I just take the function here out, data.frame, and then say run that one, it says in the base package. But then array, it's going to say it is not finding it. Take the function out, and then now run it, because that is the name of the function. It is going to say base. Okay, ggplot and many other and more packages are going to be showing out with the plotting stuff. But again, if I didn't cover any package, what you could do is go on the package here. There's thousands of these packages and that are there. Let's say you're looking for a particular package like ggplot2. If you just say install and then type in ggplot2, right away, as soon as you type in ggplot, and notice ggplot2 is showing up there as a helper. If you're looking like, okay, I want to do my, so let's see what other ones are with my, so MySQL or Oracle. As soon as you type in Aura, and so Oracle package is going to show, or MariaDB, and it's going to show. You just write a little bit of it with the same kind of case sensitivity, it will find the package that you're looking for, or SQLite, and right there, SQLite, and SQL is there, SQL parser is there. So anything with a given name, tidy, as soon as you type in tidy, everything with tidy is going to highlight. Now you write one more character, it's gonna filter to tidyverse and tidy VPC. And then VR is gonna only do that. So now if I just go this one, now I have option of installing it with its dependencies and click on install. If you have already installed it, you don't need to install it a second time. you could just update it. Yes, you can click on update and then look for the packages that needs to be updated. You highlight it and just click on the select all or do it and then install and update. If the package are not, updated, you can update it that way. And then there's also section for files and section for plots to get it. I'll show you next. So let's get to the data sets and data visualization. We did it. And then I'm just saying thank you for watching. We're not done. I'm just done with this structure of the course. So now I'm going to go to the data frame. And the data frame we already showed you. I'm going to clear a screen here. So this data frame, we already showed you the whole thing. I'm going to go quick over it. And so you can also, like we were running it one at a time, you can point here and say source it. When you source it, it uses the name of the dataframe.R from the directory that this program is found, which is demo program R. So my current working directory, get working directory, is pointing to that directory users Wahid OneDrive document. But at the time of this one, I have loaded this one on this one. So when I do a source on it, it is going to automatically, every time I source it, it's going to just run that one. Source C demo and this from that directory where my RStudio, I have opened the file from that location. You can also use set working directory, working directory of this one. So I could say set working directory and then change the document to this. So if I do this one, which is C:/demo/ actually is the / because it's the GNU minimum desktop terminal. So you come here and say clear screen and say uname -a and say min GW64, meaning minimum GNU for Windows 64-bit. This is the operating system. So when you do get a working directory here, you have to use the / like Linux style or Unix style programs and then R. So if I just set that one, my current working directory, get working directory, now it's pointing that. And then whatever I wanted to do, I could just, when I source this one, it will just source that data frame from that directory. And then this one is basically all the vectors and everything. And at some point, when I did the data frame, I just assign everything to this after all this declaration right here. This part is just declaring this. And then at some point, we print data frame, it's this. So this is done. And now I'm going to show you the message. So message is when I want to write a function, or you could write function many ways. I'm going to show you a number of examples. But as I'm going through the write, I'll demonstrate something here, and then I'll just explain each one of them separately as I go through the R script. So right here, write the message 5 times. If you want to write 5 times, you say for num and 1 to 5, whatever the message is passed into this function, which is returned into the message as a function, and this object becomes a function. So now I could get this one and then say for num and 1 to 5, and then say whatever is the number, cat the number, and then write the message that the user wants and do this one. Cat new line at the end of it. Now, welcome to R programming. R is cool. So let's say I run this one. From here, if I just run it here, rather than sourcing it, I could say, okay, now run the welcome to R programming language 5 times. So the message, because we did pass it at 1 to 5, whatever the message is going to just write to the user 5 times the message that we passed on to this function message. Isn't that cool? And then now R is cool. Yeah, so R is so cool. So now it's going to say R is so cool 5 times. Now I made the number of messages, how many times you want to write a message. By default, the other one was doing 5 times. Now it's going to take 2 arguments. One is the message, the second one by default, n is equal 3, meaning that at least default 3 times. But if the user chose to define it, then run it whatever the user chooses. So in this case, if I just run this one just says that I run the script, the function there. And now if I just say, okay, give me the message 3 times. And then by default it's 3, and it's going to say that 3 times. Now this one is going to say print it twice, it's going to do twice. The second one is going to say 5 times, it's going to write 5 times. So whatever is the message and the number of times that you want to do it, you have control over it. Isn't that very nice with our programming language? You could do it in every other programming language, but how easy it is there to just have 2 parameters, one default values on message, and go to a for statement, for loop, and or you could do for like this. Now, one thing that I'm going to show you here, since we discussed this, I'm going to clear my screen here and then say, let's make this screen bigger. And then I could say ls and then show all the variables that I have there. Okay, so now I have a lot of them, right? One of the variable is called message right here, right? Another one was number of messages, right? So I could just say, well, let's just say, what is message? If I say class of message, then you could see that is a function. If I say message itself, it's going to just say, write the function itself. You could see that it is saying that I'm a function. Use me at this bytecode. This is the definition of my function. So if I say formal and then say message, then what is that going to give you? It's going to give you the number of arguments that are passed on. The other function that we did was a number of message. So that one had 2 arguments. Number and num underscore MSG is going to say there's 2 variable. $MSG is the message, and $N is the number. The default value is 3. That's cool, right? If I want to get the body of that one, I could say, give me the body of this function. Now it writes you the body. If you want to get the body of message, that also give you the body of the message function. Very, very nice way to just look at them from your program here. So this formals and body is not just for user-defined functions. And so if I say, give me a body of factorial, notice that the body of factorial, it is using the gamma plus 1 factorial. You have to type it correctly, gamma plus 1. That's how you find out that factorial of 5 is equal gamma plus 5 plus 1, because the body of that one is going to just do the same thing there. Okay, and then obviously factorial of 1 to 5 is going to give you factorial 1 element 1 through 5, which is the 5th one is 120 and the first one is 1, and factorial of minus 1 is equal gamma x plus 1 none, right? Because that is not there, but 0 is equal 1 and 1 is equal 1. So you have to know those one default value. Any negative number is not defined, none. So later on, I will show you the functions that I did here. And because we're talking about functions, I want to make sure that you understand based in other packages. And then let me just go to the functions. Well, this video is going to be forever. Truth tables and then demo one. Yeah, functions here. So let me just do a quick thing on the functions, because otherwise I will be forever here. I'm gonna do it a little bit faster. So our functions, functions are user-defined functions or built-in. System, the built-in functions or within the packages like base, sequential, absolute value, summary, sum, production, as the all of these ones are system functions. Factorial, file, .info, they are defined in a package. And then stat dot standard deviation, colon standard deviation. Denorm is in the stat time series, and then so on. So their info is on the file system. File show their last video I showed you. But you can also have user-defined function that is not a function that is already available for you to use. So you define it based on that one. So in this case, I just wrote a couple of functions to do something similar. So like sum of 1 to 10 is already defined as a, to run this one, you basically say, give me a sum of 1 to 10. Now, if I just wrote a function called total x, whatever is the number here for n and number and x, whatever is the number, just add it up and return that one. So let's see the total. I run this one and then it runs it. Now I say, give me total of, did I run it at all? Total 0. Yeah, error and argument missing. So different way of doing that one. At this time, I'm just returning this one. Let me run this one. So here I'm looking at the total, a function and num. The value of whenever you add, you should add it with 0, so you don't get the number. Whenever you multiply, the default should be 1 to one multiplication. So this is why total is defined 0 with addition. If a value is missing, you can call this if missing function and you just check it and stop it. Otherwise, you just do add the number that is passed on with total and return it. So now let's say 1 to 10. If we add it, and it's going to just add all the numbers and with 0. And then if we say 1 to 10, well, with adding in 5 each element, and say 1 was with 5 is 6, 2 with 5 is 7, and so on. So each element-wise addition, we could do that one. Now with 10, 1 and 10 is 11, and then 10 and 10 is 1 at the last one. So now this one is a power function. Power function is going to just give you any number. If it is not missing, you just get the power of it to the power of whatever number the user defined. So here, if it is missing, I say error pal argument num is missing. Do I stop on it? Otherwise, it's going to just do num to the power. By default is 1. So if the user define a 3 or 5, then I just give the number back, because any number to the power of it is that. So let's run that one, and it's going to just run it. And then now say power 5 is going to say 5. And then power by itself is missing a value. Power 5 2 is 25. And power 10 2 is 100. And power 1 to 10, every number is to the power of 2. 10 to the power of 2 is 100, and 1 to the power of 2 is 1, and so on. So you can see that is also correct. So multiplication, notice that the multiplication is default value is 1, because you want to multiply a number by 1, you get the number itself. If it is missing, you have to say that you cannot have a missing value. Otherwise, you multiply by the number that it provides. So multiply, if I run that one, and now we have multiply 5, and missing value 5 to the power times 2 is 10, and then 5 times 10 times 2 is 20, and then 1 to the times 2. Each number times 2 is 1 times 2 is 2, and then 10 times 2 is 20. The factorial, I wrote the same factorial function with fact. And instead of calling factorial, I'll call it fact. So you could see that it is there. And then factorial of 1, if it's coming, you return 1. Factorial of 2 is, 0 is 1, and then factorial of 0 is also 1. Factorial of missing value is the same thing, that is fact of -1, and then factorial of 3 is 6. Factorial of fact of 3 is also 6. Factorial of 4 is 24. Fact of 4 is also 24, and 5 is 120 for both, and then 10 is the same number for both functions. So notice that if I say a body of factorial, this was saying gamma plus 1. But if I say body of fact, is because it's a user defined, it's going to show my function that I wrote here. So this is how you could tell. And then if we say formals of factorial, to see how many variables it takes, is $x. And then formals of fact is taking 2 arguments, num and $sign fact. You could just define it differently, depending on what you're looking for. And obviously, this one is much better way, because I did not check for element-wise factorial and other ones, but you could modify it the way you want to do it. It's up to you how you want to do it. Yeah. So we are done with this function also with factorial, and let's go to the next one, which is I'm going to go back to this list to make sure that everything on the left side is covered. First, we go to a structure, we covered data, we covered data frame, messages covered. Markdown is very easy. The Markdown I'm going to cover next. So how you do an introduction to Markdown? Basically, if you go under File and just say New File, you can just have a Markdown R script or Markdown file. If you just do a Markdown file here, obviously you will create it one, and then just assign it and everything. You could do that one, but I have already done that one, and I'm going to show you this Markdown here that I did here. So by saying file, let me just see where it was. I did new, and then somewhere Markdown file. Yeah, that's the one. So when you do that one, it's gonna just give you information that you can say title and then author and all that information. So this one is basically kind of like YAML kind of syntax, that it gives you a title, and then almost similar to JSON, but this is YAML syntax. So it is a variable and then a value, key pair value, right? So here on this one, I'm having this one, you can even do date within the single quote, a backtick, we call it backtick, which is under the tilde character. And that one is backtick, and then you could just use system.date to produce it. And then here, there's the tree backtick. And then if you want to run the bash commands, you can do brace and then bash automatically allow you to run uname -a, pwd, date, whatever command that you could do at the terminal level here, you are allowed to run it here also. So all of those information, I just did that one. And then here I'm getting the output for those commands, and then for the bash commands, and then here I'm just doing another R commands. With R, I could create a matrix, and then once you do this brace R, and within the tree backtick automatically, and close it with the tree backtick, in between you can put any R syntax. And here is some syntax that I used. And then if you want to do Python, you just, instead of R, you put within the braces Python language. Now I did for this, right? So, and then if I want to print bold, you put 2 asterisks here, you put R version information, and now this one is going to do R version, platform and machine. All of this data is coming, and then if you want to load libraries and requires those ones with bold and other ones. So the syntax is continuously repeated, similar stuff. And then here's header, how you want to print out a bigger versus a smaller and everything, how you do listing, everything. So item-wise, order list, non-order. And then the program that it is running it, here is this, R Markdown. This is the R Markdown documentation. And then you could see, including like if you want to plot something, you get this one, and then R pressure echo false, plot pressure, and we plot the pressure. And then similarly in these other ones. The examples is too much if you want to do that one. So all you have to do is, in order for this one to be running there, as I showed you on the documentation, that by default it creates HTML. You can also want to get the output on PDF or Microsoft Office. You have to install additional one. So if I just go right here and say, okay, on KNet, run this one, and then all I have to do is save it once, and now it's going to run the package there. It just did, and now it's processing it. It's creating the first markdown, and now it's opening it in Markdown HTML page. How cool is that? Introduction to R Markdown by Wahidullah, and then the date is 9/24, and then these are list of bash lines. You name PWD, everything, and then this is like a matrix that we created on our language, and this is value of them, and then the data frame. Here is the Python that I did within Python for num and range of 10, and then print num, and right here, and that does write that hello Wahid 10 times, or 0 to 9 times, which is 10 times, because the index on every programming language starts with 0 except R. R is start with 1 because it's a vector. And then x for x and range of 100. This is like a kind of Python less comprehension. Less comprehension that you could do it within one line, range of all the numbers that are even. Print x, and then you say between 0 to 90, between 100 with module 10, it will write all the even numbers. Or that version is giving you the version with all the minor version and then major. Last time I showed you. Or dot platform give you the platform that you're running on Windows, dynamic link libraries, and all machines, and so on. How load a library and the file system, all of that one is demoed here. And then list of variables and functions, and then header information, markdown, and then finally the plot of x to the power of y cubic or something, whatever was that expression that was there, and that we did. Okay, so I'm gonna close this one. I was just curious about the plot, and the plot cars. Yeah, pressure was the plot of it. Plot and our pressure. And now we're coming back to our version. We already covered this one, so I'm going to close the one that we covered here, because I don't want to just keep clicking on these. Structure we covered, or message we covered, and then this one is what is this one? Structure. I'll leave the structure for now, because we did a lot on that one. We may have to go back to it. So our base packages, we did talk about base packages here. File system, you could see that when you do a file system ... all these packages are available here. So, and last time we did path. So I want to just show you the path. Last time I did not cover it enough to explain to you. I'm going to do that one right now. So when you do fs and then say path, if you just type in this and do not give an argument, it was giving 0. The reason it's giving 0 is because this one requires a string. So get working directory of this one, current working directory, now you get the path. So because get working directory is where I am there. So if I just say get path of this one within C:\Windows, then obviously that is gonna give me a path of that. C:\, path, let me just see, is an unrecognized escape sequence. Oh, because this one is the Windows / it has to be the Unix / that would give you that one. And then if you just say path of system 32, but we are giving that path information. However, a get working directory is this path. So if I just say get the file system.path of that is gonna give me that information. File system and then double colon, which is the scope resolution, not one colon. Okay. So you could also concatenate it with other variables and other stuff. We could do that one. I'm curious just for file system : path of let's say C / demo / programs / R / let's say what is the name, structure.R. Let me just move this one out of the way, and then I say structure.R. So if you give the full path of the program, it gives you the path of that. If you give it to halfway to up to this one, it will just say that's your path. So and the full path file system path will give you that. And then let's just move this screen back. Now here we're done with it. I'm gonna do this, and then we did the stats stuff. With the stats, you have a lot of the data type also. You just have to tap here and you see all of the statistics packages that are there, time series and everything there. Okay. So, and then similarly for file system, tap that one, I'll give you all the file system. Last time we showed you some of them. The dplyrs, tap it, and then you get all of that one. Okay. And then, so that would be this. I'm going to close this one also. And then the next one is package. Package, we covered last time the dot package. When you run the dot package, it's giving you basically, let me just take this one out. So when you run the dot package, it's giving you that. And then now if I just run this one that available, then you can see that all dot available is equal true. It's gonna list you all the packages that are loaded, available for me to use, including the DBI, CLI, blob, and then bet, and so on. So all of these packages are available for us to load it and play with it. Now left.path, this is going to tell you the current library of the paths that are there. So if I just say left.path, let me just see why this one is, yeah. So if you just take it out and then look at the left.path, it tells you that where the path of the libraries are. So under the R, when libraries, and then also the library path here that is there. So if you want to get the dplyr library loaded and then require then you can just do a library of fs or require fs. That one you can load the file system. Here left.path, we already checked that one. Set working directory. If you want to set your working directory to the Windows System 32, I want to just use the Windows DLL libraries. So by doing this one, now you can do a dynamic.load and then by.dll. Since I set my DLL, now I just loaded by the .dll. Or if I want to do the kernel 32 or load it or detach it. So if I do the load dynamic load kernel 32, it will load that one. And the detach, if you want to detach a package, you could do that package. Since dplyr is not loaded, if I just do earlier right here, I did not load the dplyr. If I just was doing this one, and then this one is pound, and then if I run this one, it will load the dplyr package. Notice it shows me all the dplyr package. Now I'm here on the detach. If I detach it, it will detach it here. You can see that the dplyr detach package dplyr unload through. Or what it says tidy or cannot be unloaded. So when it says these other ones, because our tidyr is loaded, you cannot unload it. You have to unload the tidyr first. And so right here, when we say detach this one, it says that, and then now meaning that I have to do the dplyr package, unload that one, and then now that one is unloaded, detach, invalid name, dplyr. So somehow it is getting confused. Let me see why. I'm gonna move this one a little bit up. I'm gonna say, let me just say tidyverse. I wanna see if that one is loaded or not. Yeah, it was loaded. Now I detached it, and now I say detach this one. It is not loaded anymore. It is not there. So the tidyverse unload that one also, dplyr. But if I say load it here, library dplyr, and that one loads it, and the following object mask, and you can see that some of the objects are used on both of them. So last time we did a find on those two packages, and then you can see that the filter was used by both. One was on the start, one was on base, and then now you can just do the same thing here on the filtration. Dplyr requires, and then detach this one. Since it's tidyr. So let's see, library tidyr. If it is there, I'm gonna detach tidyr now. Load it first to make sure it is there, tidyr, and then now detach it, and that detached it. Now dplyr, I'm going to try the dplyr package. Unpatch the dplyr, that package is not there. It's not loaded. So we're all good. If it was loaded, I could have just say detached, but it's not loaded. Or I could have just loaded and then unloaded. Doesn't make sense. And so this is already unloaded and it's not there. Now I'm doing this one, creating a kernel base vector or object. This kernel based object is creating this dynamic link library. So now I can just get a view of it, get a head of it, get a listing of it, and get a storage of it. There's so much thing you can do on the Windows kernel DLL libraries, the system libraries, right? So let's do a few of these ones. I wanna just run up to this point. So we run the KB, and that did it, and then now we're gonna view it. Notice that it creates already the view for it here. Kernel base, and then all of the list, and then the linked and all the characters on all the definitions, handles and path and everything. Here's the path of that kernel base on Windows System 32. That's neat. So I'm going to just say, give me the head of it. And now you see the head of it is right here. And the kernel base head of it is kernel base. And the path is this dynamic link library, dynamic lookup, and then all the handles, information, and then DLL info reference. Some of the things that are very systematic, right? So we did dynamic bind, and let me just see where I'm right here. Head, we want to list it, and then you can see when you do lskb, it tells you that dynamic lookup and force this. And then the storage of mode of it, if you want to see, is a list. Class of it is a dynamic link info. Print the structure of it, and you can see this is the structure of it. We could do load dplyr and then do a glimpse on KB, and you could see maybe you get a more structure, but it's all these informations. Okay, so that's for the package. And similarly, if you want to detach a library, you do that one. So we're done with the package and dynamic link libraries, and then I'm going to save it, and then data analytics. Okay, this is also cool. I'm going to show you this. This one is data analytics as well as data visualization. I wrote this one for you to see, like I can create a histogram in R and how you could plot it and everything. And with some kind of system programming and some kind of data analysis, we could do R norm and then distribution normalization of that number, and then random number generation. This one is a start to stop, 1 to 360, and with 90-degree difference. And then we just go to run if this one, and then histogram of it, and sleep. And then this sleep 1 second is gonna just give you a nicer screen of colors on this one. Plotting it with 1 second delay, so you can see it on different set whenever I plot those ones. And notice that I have plot women data set, empty cars, iris data set, and then some sine and cosine functions and everything, and just data analysis and data visualization. So I'm gonna run this one and source it here. But before I source it, I want to just open this screen here for you so you can see the plot. I'm going to click on the plot here, and as you can see, there's nothing here plotted. But now I'm going to start the program with source, and then we're just getting the plot of it. Notice that because of my statements, it's going to do 1 second delay, and it's going to just give me all kind of data formats very nicely with different data sets and different ones as it goes. So the last information was done, and then now head of women count is also given here. This is how this program is there. So if I just refresh this one and run it one more time, notice that every time you source it, your screen is going to just get the plot with those ones and definition. Some part of automation, whether you do sine, cosine, tangent, or iris data, or some other data, or you could do empty cars or whatever, you just get the output there. Okay, so that is an example of data analysis and data visualization with some commands. And notice that here, some of those plots, every time I did this sys.sleep 1 second, I wanted the system to delay 1 second between the plots so you can see it. And then also here, with the colors. I just used a different kind of color within each of those statements, so I can have different set of colors printed out as it goes there, right? And this is a part of the parameters COL for color. Line width is 3, so you can see it a little bit bigger on that one. So I'm done with this one. Now let's do this one, read demo, readxl. So you can also work with Excel spreadsheet. But the Excel spreadsheet, if you just do it right here, and the library is tidyverse by default loads the read Excel. It's not part of the core tidyverse, but it does it, and then you can also load it by using library read this. You can also install it with this. Since I already did it, I think when you do this one, require a readx, and you just run it. And now notice that when I do this a readx example, so by default, as soon as you say read x require, that's one loaded. This second one, an example function, is going to just show you what are some of the Excel based data sets that are available as examples that of XLS file or XLS X file. So read underscore Excel reads both of them. And so that is the one. Now here I just say read XLS data sets.xls, which is data sets.xls, this file. So if I want to open that file, I just read this one right here. And that one is just saying that this is the path to the full path of where that dataset.xls is example. And now if I say read XLS without loading the package, I can call this function, and that way without loading it, I could do that too. So I'm back at that one right here. So that one just read it with this data set, and then here are the values. So I could go to the top, and then this was my statement, and this is the output. You can see there, it's an Excel spreadsheet. The data types are showing, the number of rows and number of columns, everything is shown here. And then if you do just this one, XLS, we did this one, assign it to a variable, and then later on print that variable, we get that one. If you want to get a view of it, you get a view of it, and if you want a plot of it, let's get a plot of it, plot of XLS. Right here, now I'm going to say plot. It plots it for you, and then plot with different colors in this time, and then type of it, if you want to get the type of it, is a list. Head of it is that, and tail of it is that, a structure of it is that, and then glimpse of it is that, and so on. So dplyr package with the select, you want to pick up a particular one, and then plot for that part with the red color and between column 1 and 2, and then I believe we're done with this one also. Yeah. So I'm going to just exit out of this one also. The next one is database. This one is a little bit more. Before I go to the database, let me show you the truth table. Truth table is a faster way to do it. So if I go on the top, here I wanted to show you an example of how you can print out logical tables, whether it's true and true or true or false, or something like AND operator, which is this symbol, or OR operator, which is this symbol, or NOT operator, which is this symbol, or NOR operator, which is the NOT of OR, or XOR, exclusive OR, which is this symbol, this function. So if I just run this one, and this program is very cool, all it does is just print me a table of content for different value. So if I just make this one Shift Control 2, this is my main screen. You can see that on the output of that program, when I source it, this is sourcing through table. All it is showing the end, which is this symbol, true and true returns true. True and false return false. True and true only returns true, and then anything with a variable false will return with and of it, it's going to return false. So one or more variable, if it has 4 elements, one element is false, the entire thing is false, the end of it. Now, on the vice versa, if it is or, one element is true, and true is going to return true, true and false is going to return true because one of them has to be true, the rest of them doesn't matter. So with false and false is going to be the only one that's going to return false. That is the Boolean expression. For this one, you should also watch my video with De Morgan's law. Augustus De Morgan's was a British mathematician that he came out with discrete math kind of Boolean algebra. Boolean algebra was actually George Boole. And then De Morgan's was induction law, disjunction, conjunction, and negation. Negation meaning anything you negate it. A negation of a true is false, a negation of false is true. So negation is the opposite of whatever the value was true or false. Negation of 1 is 0, negation of 0 is 1. True is false, false is true. And here, the OR statement returns false only if both of them are false. Everything else is going to return true. And then the negation of not true is false and false is true. And then for the NOR, there's no statement on OR as a NOR because they know that when you negate the OR statement, you could just get a NOR of it. So that's what I did here. I just negate the OR statement and notice that wherever this one was saying that it's true, and the NOR of that one is false. And wherever this one was saying false, the NOR of that one is true. So NOR is the opposite of the OR. Whatever's OR is returns and not of that one is NOR. Not an OR, negation of OR. There's also exclusive OR, meaning that at least in order to return true, so true and true is returning false. And then false and false is also returning false. But if one of them is different than the other one, then it's going to return true. That's XOR. So that's the exclusive OR. And then exclusive OR through table, I think I printed that one twice. I'm not sure why, but doesn't matter. So now we are done with this timetable also. I'm going to go back to okay, so let's close this one also. And then demo 1, this one is very simple Python program that I just wrote. You can write Python within R script and name it demo1.py. And notice that whatever the extension, now if I source this one, it's going to run the Python interpreter against it. And it's going to just execute it. That one. So you see, like as soon as you source it, it's going to run demo.1.py as if I'm inside a Python interpreter. So any statement that I do here, I don't have to just do this one. I could just do any statement, it will print it. For example, let's say I say here, say for num and a range of 1 to 5, let's say 1 to 5, a range of 5, let's say 5 numbers, and then I say print, and I'm going to say f a string function, and then say brace and num, and then I'm going to just say R and Python or programming languages. So now if I just do that, the statement, and then run it, and notice when I do this statement and I say, go ahead, run this one and run it. And it is going to run that statement. So it's waiting for me to say run again. And it's gonna say that, and then now it's printing. So if I source it the first time, I clear my screen here and I say source it, source the script, it's going to run the previous script, whatever I had it saved. If I save this one, say, now save this one with this name, it has to run it like one instruction at a time. I'm already out here. Let me just clear the screen. I could run it also on Python in the terminal. Let me just see it on the terminal, see what character I am. Store.py. So this is demo1.py. I could say Python demo1.py, and that would just run the program there. But because I haven't saved this one in the interpreter, if I just want to save it, let me just do this, and then I say save it. I click here. Now demo1.py is there. If I just run the same program, now cat -n demo1.py, it is now on this. So now if I say Python demo1.py, it's gonna run that one, or in Python is cool. So I just modified it. Now I can source it here too, and that say what happened here. Some extra lines or somewhere there. Now let me clear this screen here. Oh, I'm inside the Python interpreter. So I'm gonna just say quit out of this one inside Python interpreter, quit. Why is, oh, I'm inside the console. I wanted to exit out of this one, quit. Okay, somehow I need to know where I am. I'm on terminal, and then here on console. And then on Python console, I can say directory. Yeah, I am inside Python, so I should be able to type in quit here and then do this one. It says could not do it, system exit. Inside the Python interpreter, it's not taking me out here. So if I just go here and say Python and then say exit, this is how it should exit you out. Or you say Python, you say quit, it should take you out. But somehow it is the console itself is hanging here. So all I need to do is the for statement here, and it says here at the stop. Oh, right here, let me see. Okay. So I am going to say save, and then print, all done. Let's see what this one do. I'm gonna say save it, and then say Python demo1.py, and it says all done right there. You can see that it's doing it from the terminal. However, on the console itself, it is just keep looping onto this. I can run the program here as if I'm inside the functions and look at all the Pythons. OS.system. Let me just say import OS.system, and then I'm gonna say clear screen. Yeah, this doesn't mean on the RStudio, it doesn't mean anything. So if I just run the directory command, it runs the directory, and then quit out of this. Yeah, looks like that is sitting on the R console till I run it from this other one. Let me just here say something quickly, say 1 to 5. Just print this one, run this one. Yeah, now I'm back out of the, so quit without the parentheses would have taken me out of this one. Inside our console, once you're coming here, let me just take you back there. So this is how you find out that one. If you run this one, source the script, now I'm still inside the interpreter. But if for any reason, I just run one statement at a time, and now I'm inside the Python interpreter, I run it. If I type in this quit with the function, it's not going to understand it. The way you quit out of this one, you just type in quit. Now you're back into R. Okay, so this is how you get this one. So we're done with the demo one also. We're done with functions, factorial and everything. We did that one. And then plot. So since we were talking about Python, I'm going to demo the functions that I wrote in Python that you can open it in Visual Studio Code or Python itself, or then just inside the R language. The only difference is from the matplotlib, import pyplot and asplot and numplot. If you're on the terminal here, and then you clear a screen and then type in here, say pep list. So this one will just run all the Python packages that are installed on the system. Within this virtual environment, you have to make sure that those two libraries are imported. So if those two are not installed with pep list, and say find /I, and then I say matplotlib, if that one is already loaded, you can see find is not found. So instead of find, because it's a Linux kind of syntax, and instead of find, I'm going to say grep -I. And that would find it. Say, oh yeah, matplotlib is loaded. So now I can do it. If this one says when you run this program within sourcing it, it says that matplotlib is not defined, then you need to do a pep install matplotlib. That would just go on, sorry, not pep install, and then it will go to the packages and load it. Since it's already loaded, it says requirement already met, right? So now I can do the source of it. Notice that numpy is another package that I'm doing it here as np loaded as another library. So here I'm defining numpy.arrange to do the pi stuff, and then numpy.sine and do the same thing for cosine, same thing for tangent, and then do the plot x label, y label, all of that definition, and then I will be able to plot in, and then here's the output if you source this package I'm going to show you. Just the package information, as you can see the examples here, I can go to next and next, and then you can see the graph of it is a little bit kind of hectic. So I'm gonna just say for this one, let's see if I can just make the screen a little bit smaller. If I go back into files and refresh this one, do this, and Control-Shift-1 will give me these windows, and then the plot here was too small here. So this time if I source it, let's see if I can source it from right here. Source the script, and then you do the plot. Notice that plot that looks a little bit better. And then you can just go the next one, and so on. The graph of it is done. But for this one, when you're looking at the graph of the different one of them, I will show you that when you actually, you can zoom inside here, you can go out and so on. All of that one detail are there. But it's much nicer if you just do this one from command line of that functions. So if I go on the Windows directory, let's say I'm gonna go to clear screen, and then say cd to demo /program /python, and then say clear screen directory store.py. There are some of them, and then plot sine cosine. So if I say clear screen directory plot, these two functions are the one that I use. One that only does sine and cosine, one does sine, cosine, tangent. So if I just run the Python plot underscore sine underscore cosine dot py, and then it will print sine and cosine function. You can see that the graph is looking nicer. And then that's from the operating system. And now sine, cosine together. And similarly, if I want to do sine, cosine, and tangent, it's there. You can see this is cosine, and this is the graph of tangent. And this is sine, cosine together. And then sine, cosine, tangent together, all of them. You can also do it from code, from Visual Studio Code. So if you just want to open this one inside code, you could do the same thing here, and then open it in the code for doing the graph of it from the code running it. This is an example of it. We run it from RStudio, we run it from operating system, and we are running it from code now by opening it from code. Let me close some of these other ones. Okay, so where's the Visual Studio? Yeah, it's already open here in the background. So this is the program to do it. And if you want to compile it here, run it, and it's going to run. And it's going to give you output here for plot sine function. And now it's cosine graph function. This is the graph of tangent. And this is sine and cosine, as you can see, and tangent together. So here you can also do a zoom on this one. You can click on zoom and then just highlight some area here. You can see there's three lines here. So for sine is blue, and cosine is orange, and then tangent is green. You can see all of that in definition. And if you click on home back, it's the whole thing. And if you want to go back to the previous one, you can go previous one as you see that plot. If you want to go forward, then it's the next one. Okay, and this one is if you want to adjust it based on wherever you want to adjust it. I'm going to close this one. So this is inside the Visual Studio Code. Since I'm on the example of this, I showed you that I'm going to do a example on Visual Studio Code for R language. So let me just open the Visual Studio Code inside of R as we did this one. And so I'm going to go through the command prompt here, and then inside here, cd ... and directory cd to R language, clear screen and clear screen, and then directory. So let's see the R language. If you want to just run of these, one of them on the inside the Visual Studio Code, we just are going to look at which one is a good example. What is R, readxl, structure, or let's just open the I think we could do it the R database because I'm gonna cover that one also, but I'm gonna do a quick one on message.r. So I'm gonna just say code and then message.r. So we opened this one as a quick reference to see on Visual Studio Code how you could just run a function here. So this is some of the extension that you have to load, and you can go here, say extension, and then just on the R, when you go there, you just say R extension, R tools and everything, you install it, which I did already. So once you do this one, it says that our tool is installed. So then you could just come back here, and then right here on the main program, you could just run it. And then here's the output that you say that all of the output there. You can also open a terminal and then run the program from the terminal by going to that directory. So if I just go to cd to /cd to demo /program/r, and then clear screen star.r, you can see that programs are there, right? So you could say clear screen and then source messages and .r, message.r, and then since it didn't run it like this, maybe the source is not recognized there. Yeah, source is not recognized, so you have to do it just like this, and that would run it within the R base, but whether the output is going to show on there or not, that's a different things within R. But we did run it within the R here. We got the output as you like that way. So that's another thing. You can also use another one, like for example, code functions.r. If you just do that one, it will load the functions, and by just running them, you get all the functions output out one at a time. So right here this is your program. You just basically once it's loaded everything together, you could just say run it, and here's the output for functions.r. Error PAL argument num is missing with no, because we did not pass it on to the environment with the PAL function. We're just doing it here. So the way we did it in RStudio, we were doing it with source of that one. So that's the different thing. You can always say on the Visual Studio Code, you can just set up the environment to read it, and that is a setting on the environment of RStudio. I don't have time to explain all of that. And I'm going to go to Jupyter Lab, which is another IDE that I told you on this one. And then when RStudio, I believe, sine, cosine, we already covered, our database, and then our kernel. So what Jupyter Lab, in order to do it, you need to do install.packages devtools. Once you do the devtools, and then do this second command, devtools install GitHub, and then interactive kernel or kernel, and then kernel, do the install specific spec, and then start Jupyter Lab by typing Jupyter-lab at the command prompt, which I did, and that opens up Jupyter Lab at this port. By default, if you don't have any of these ones, you go under the main one tab, you have a notebook. Under that one, by default, you have Python, and then if you want R, it will load it for you as well. So it will load that one. Okay, and then now that one is loaded, you can open the R interpreter or Python, it's your choice, and if R console or Python console, and then the terminals and Markdown, all of that one are options, or files, and if you want to do it. So here I have some demo for you to show you already. I did this one earlier. I'm going to just demonstrate quickly. So if you want to get information on R, like system function, you just do question mark system, and it books the question operating system commands here. So some of the commands you can run inside the system, and you just pass it on, and you will get output of it. Another statement here is the same logical statement that we did earlier. But here I'm also doing true and false. Notice that when you do s true and false, if you run these statements here, it will just say that a lot of those statements output or logical false and true. Let me see if I can slow down on this one, because this one is true or false. So it's gonna just give you true or false, and false is gonna just say false, because and statement, both of them has to be true in order to do it. True and false is gonna say false. True or false is gonna say true, or is one of them has to be true is good enough. 5 and greater than 3 and the other ones. So every one of them that you just run this statement, it will just give you the output based on those expression. And like 5 and greater than 3. So we have to like maybe slow down to just show you these ones one time. In this one I already did. I'm gonna delete this one from here. And then this is much easier to show here. And then I say, let's say, I'm gonna say Control X. So at this time, I'm gonna run only this one and say, show me the output. Say, this is logical, true and false, because I say the type of. Is true and false? It's false, because that one, I say the true or and false is also false. So now I'm going to take that one and just put this one, and I'm going to run these statements, say, give me the output of this one, true or false is true. This one 5, and this one of them has to be true, and then 5 is greater than the 3, true, and then and 1 is less than 5. Both of them is true, so it returns true. And the second one is 5 greater than 3. This is or. One of them has to be true, and then still true. Is true 5 and 5, is true 1 and 5. That's also true. So everything here returns true because those are actually true. This one is also or statement. So even if one of the statement true and false, this one is false, but this one is true, true or false, and then it's going to return true. And true and false, or true and false. So this one is this, and this one is that, and then already we had true and false. Type of this one, and this is going to go say logical. This is a class and T. It does coercion with based on the logical. So that is converting it. And then here, C1, A through F. C1, we get the data type. Let's see if we could just, yeah. So each one of them, we already went through the vectors and other ones. I'm just showing you a quick summary here. It's a lot here. If I had time, I would explain it to you, but it's pretty self-explanatory once you understand the functions and why you pass in those arguments and what you're checking on it. And right here is the output of them, each one of them. So warning message in 1 to 5, vector of 5 double elements. Numeric expression has 2 elements, only the first one is used. So that one is same example of the one we were talking about earlier with 2 elements assignment versus 3 element assignment. 1 0 colon 5 D3. I believe that's the one that were assigned there, but we wouldn't tell until we just cleaned it up and went through the lines, vector of double elements, and that's class D3. So class D3. Where's class D3? Yeah, class D3. So this is the one that it is giving that error. Yeah, we found it. So now if I just change that D3 to say assign it to 1 to 5 colon 0. So we say D3 1 to 5 of that one, assign it that one. We may not have an error. This time, no, warning, this is 1 to 0, 5. Numeric expression has 2 elements, only the first one is used. So that value is in only 2 elements as used at the first one. Okay, we don't need to do this one because I'm not sure what I meant to do that one at that time, and that's good enough. So let's just do close this one also and go to this demo one. This one is demo is the logical statements. You can also check for true values, and you can see that I just run those ones and get it. If you want to get the symbol of this one, like help on it, you can get this with this two symbol and then that would just run you and logical operator explanation here. And then there's 1n versus 2n. The 2n is usually when I use the if clause, and the 1 is for Boolean one element wise operation. You need to know that one. And then the rest of them is negation and or and everything here. So demo one, and then if you want to just comment this one out and then don't show me the output. The output is here. This one is the help on the, if you don't get the help on this way, you have to do another way, which I showed you earlier. And so that one was to help of this, and then you could do a fuzzy logic in here. No documentation found this way. Percentage and greater sign this one. So I think the use of the symbol shift control M is percentage greater sign. So if you just want to get help on the Jupyter Lab, is a little bit not working that way, but you could do question mark double quote shift control M. Sorry. It just created a new one. Okay, let me just do question mark, double quote, shift control M. So you could get the help on this one like that. That would also produce you the output. No, let me just see what. And then maybe there's a space. Yeah, there was a space. So you can see the piping is showing up here. That is what the piping is there. You might want to also get this one under help, but on Jupyter Lab, if it doesn't work, it's just a Jupyter Lab feature that is missing. So here you could do something like this and then run it also. And that will also give you the same output for piping, okay? But we did this one through Jupyter Lab, and that would not produce either one of them output signal documentation. Okay, so then for the launcher, yes, you do have R, and then you have Python and everything for the Jupyter Lab as well. So I'm going to close Jupyter Lab also, I don't need it. And then this another R examples of piping that I did for documentation. You could do that one as well. And then here, I'm going to just come back to the RStudio and show you the demo with this one is also done already, RStudio. And this untitled, I don't want to save it. Don't save it. And this structure is done also. The only one that is missing is the database part, which is a lot. So I'm going to cover that one for another half an hour to an hour, depending on how much we need to do that one, or maybe less, maybe 10 minutes per package. We're going to go through them, and then you should be able to get the rest of them easily by knowing one. You could apply it to the other one. So here I'm going to do our database MySQL DBI and RSQLite, and then also MariaDB. So you could say R MariaDB. So these four packages. In addition, I'm not doing Oracle, but if you have our database, Oracle database, you can connect it through the package or Oracle database as well. As I showed you on the install, when you go to the packages here, on the packages and say install, you could just type in R here, and then as soon as you type in Aura, it will say there's a database called, a package called Oracle. If you say MySQL, and then there's there MySQL, Maria and DB, MariaDB, then it's going to show that one. And then similarly, SQLite. And notice the case sensitivity, like SQLite, SQL is uppercase, IDE is lowercase. So you do that, the same packages, you can install them as a collection here. If you want to just do the Oracle, you could do that one also. So like here, I could say Oracle. So someday I just installed the Oracle server to connect to, I can just do this one or Oracle also. And then when I just run this one, it's gonna just take a long time. I'm not gonna run it because I already did for these packages. And then I'm gonna just comment this one out. And then I'm going to just say, well, when you do the RMySQL, the DBI automatically gets done. Or when you do SQLite, automatically done. So now, since I have done it already, I could just say, do this one and tab it. Now you see that all the RMySQL. And for all of them, when you do that one, the DBI package is already dependent package that is getting loaded. But the DB Connect and other ones that are using it, like DB Connect here, you could just use that DB Connect to connect it. When you want to do a transaction that is atomic, you could submit it to commit it to just make sure that it's permanent to the database or roll back. So when you do a commit, it's done. Data types and DB and disconnect. Whenever you're done with the database, you want to clear all the record set, and then you also want to disconnect from the database, DB disconnect. And then if escape string, these ones are for SQL injection, when you don't want somebody to do buffer overflow or cross-site scripting, or maybe some kind of SQL injection, and then you want to do escape string. That one is for security purpose. Exist table, if the table exists. DB fetch, whenever you set a record, we call it cursor in the database, or MySQL, Oracle, PL SQL, all the programming that we did, we call it cursor. And here is called the record set. You read the record one at a time or 10 at a time. You fetch it based on whatever number of amount you want to do, and do record within a while statement until you are finished with the record and you're done with it. Then you clear the data reset and then also close the connection. DB get exception is checking it, the DB get info. There's a lot of these DB send query and the DB get query, S table result and list tables. List table will give you the tables, and next results set rollback. Now remember the commit and rollback, and then so that's the opposite of it. DB send query and DB get query is your friend to get the fetch, and then S ID. So some of the information you can also do MySQL, and then just to the connection, and then do some record checking, show, and then like database tables. Show tables, show records, all of that one, SQL keyword summary, and so on. So now this is for the DBI. Notice the DBI, everything is like lowercase db, and then after that one is some uppercase letter like connect or can connect or call, and then the first letter is always uppercase. Clear result and all of that one. Connect this DB to connect the record and so on, right? Similarly, DB fetch and then all of that, and query DB send record, remove table, and fetch table, and so on. Similarly, for the SQLite, the functions that are available here, if you just do colon and in the tab, now you have all the functions. I'm not gonna go cover all 1,000 functions, but I'll cover you the details of what you need to know, so you can just start coding in R. And the way you do it is like you load library MySQL first. So once you load the library MySQL, let's see, something is here is wrong. Let's see, I did this one. Okay, so these ones, when you're not using any function, it does not understand. You have to comment it out like I did earlier. So when you do comment it out, then it will be ignored. All I was doing is for demo purpose, I was saying that this is tab that function name. So I already demoed that one. Now I'm gonna save this one. Now I run it and it just clear screen. Let's see, library, run, and then what is this question mark? So right here, I'm on this second one. Let me make sure. Oh, the one that is R MySQL. Now let me just make sure that there's anything here. Okay, so I'm right here. We did that one. Now I'm gonna connect to a MySQL database. In order for it to connect to the MySQL database, this string might come as a result of MySQL not running. So when I try to do this connection on the MySQL database, which is the first lines here, let me just go back right here. Connection to the world database. If I just say run, it's gonna just say, oh, and this one was returning that the database is not running. Connect to the server localhost failed, right? So why it failed? Because I'm not running a MySQL server. So let's run a MySQL server. Say, I'm gonna go to services right here, and then look for the service MySQL here under the name. And so I'm going to sort it by name, and then I'm going to look for MySQL. I started MySQL Workbench, so I'm going to go under the M, and MySQL MariaDB is also not running. I put it manual for both of them. First, let me try the MySQL right here. MySQL IDE, this one is manual, so I'm gonna just change that one to automatic, and then apply, and then I say okay. So next time I boot my machine, it will run. So now I'm gonna say run it, start it, and it will start MySQL Workbench. So now MySQL Workbench is started. I can just first go to MySQL Workbench on the command. MySQL Workbench on the command line. I could see MySQL Workbench and MySQL Shell. Whichever one I use right here, if I want to connect to the MySQL Shell, I'm already connected. But if I say, like, for example, status /s, and for status, it already connected me and there. So I'm gonna quit out of this one, /q for quit, and then I'm gonna use my SQL Workbench, which is typing here my SQL. and then MySQL IDE command line. Right here is command line also that I can connect as a client. And then here I type in my password. And then on this case, I'm going to just look at my R, what I used for my password. I used demo db12345. So I'm gonna say D3 mo db12345 bang bang, and that connects it actually, shows up. But let's go through my SQL Workbench, my SQL and Workbench 80, and this is the one. Okay, so here I use this Wahid user. I'm going to use the same one, and I'm gonna say demo. Let me just see what it was, the password. Demo db12345, and then bang. So it's a long name. Usually you want to do it shorter. Demo db12345, bang bang. And now I'm connected to it, as you can see here. So you can see show database. If I just run show database here and then say query it, you can see it's the database over there, world is there. And then if I say use world and then show tables, I'm just showing you a couple of things here, and then this is the structured query language you can do to show tables. And then you could say select a store from city, and now everything is available. Now I get there, and then where a name like, and then I say I start with K percentage, like Kabul is there, right? So let's see if anything else with that word string is there, Kabul. So I could run this one and then say, show me that, and where name like, oh, not asterisk, percentage. Percentage is the wildcard in this case. So now it shows you the name of the city that has there, including the first one, Kabul. And then you can do sort order and everything. I'm not gonna show you a Workbench or MySQL here, but I just connected. Now, if I just run this connection instead of failing it, we should succeed there. So I'm gonna say run, and then it says no documentation for specified libraries. So I don't know if what line was it. Let's see this one. Yeah, this one succeed. So now I say RMySQL get information, then it's gonna get the information on the MySQL. It says the username is Wahid, host name is localhost, and then some of the connection type is TCP/IP on localhost, and then version is 8.03, Workbench, and all that thing, list tables. So DB list tables, if I just run that one, it's going to show me that same 3 table that I was getting it earlier, right? So let me just move out, zoom a little bit. Okay, so now it is there. I think I can just make this screen also bigger. And then I'm gonna say the list table shows the tables that we were looking at, the this one. Like, remember the show tables here? Same tables, right? City and country and country language. So if I just go back here and then city, country, country language. So whether you do it inside the SQL statement or do it with DB list tables on DBI, you could do it. Now I'm running a select statement, but I'm assigning it to this query statement, SQL statement. So I say select ID, name, country code, district, population from city, order by name. So once I do this one, it will just create that SQL query statement. Now I do that DB send on this connection that I did earlier with this con right here. when I did the connection, I said connection to the Word database. So now I'm going to query it with db send query and then run my selected statement to get a record set. So when you do this one, record set is set. And now I say counter is equal 1, while the counter is not incrementing to a number of times. If there is still record on the record set, DB has completed. On the record set, if it is not completed, keep reading it. So it queries each result and then print the result and then the number of rows and everything, and then counter and increment it. While I do the counter, at the same time, I want to plot the query result with this color. And then counter +1 and then sleep 5 seconds. So before I do it, I want to move this screen a little bit this way so you can see the plot screen. And the plot screen, I'm going to just refresh it. And so it's empty. There's nothing here. Now I'm going to just run this while statement on the record set. So run and run. And the while statement, it's now plotting it right there. You can see that it is getting the data from each of those ones. But as I read the data, it just waits a few seconds and change the data sets, does query more, and each record set, notice how cool is that one, is that this information keep doing it. Here is within the while statement. I could just stop it here, say stop, I'm done with it, it's good. Or I keep looking at the data and see all the information that is changing in the graph of it is there. But while this one is doing it, I want to show you also the output of the record set here, the DB query. Each one of them is printing on the bottom here. At the same time, this counter, as it is doing it, I'm doing a sleep 5 seconds. So it is printing a plot of it, and then it waits 5 seconds, then change the color. Notice the color changing from green to red and the other ones because I put the counter, and as the counter changes with module of remainder being equal to 0 or not, I either print it in green color, which is remainder is 0, and then if the remainder is not equal to 0, then I like right here. You see this when remainder is equal to 0, I print it in green. When it is odd number, I print it in red. So I plot it in red. In both cases, I plotted, not printed. That's really nice. So it shows all the records, and at some point, when this one stops, it's done. But in order to show you more, I'm going to stop this one because this record set is really huge, right? I'm only doing 10 query string, 10 lines at a time, as you can see here. Each query comes in. If it is 1,000, I don't want to just stay all night here. We do demonstrated the plot and the examples and the color, everything. So I'm going to stop here. Now that it's stopped, I'm going to have this one and the clear result. Now we're going to clear a result and then disconnect from the table, from the database. So I'm going to just run that one again with run. This one is going to do it. And now if I disconnect it, says disconnect, now disconnect is true. And now that connection is no longer there. So MySQL connection, and this is port 333. Now I'm connecting to the sys table. Sys table, I'm doing different record sets. So let's run that one also. I'm going to go through that one a little bit quicker. No need to just explain each one of them. It's a different table, but pictures and everything else, the queries are the same. So while record set and then this and that. So now it is all done because this is green, right? So you come in here and say, clear the results, and then also, let me just see. Oh, I was never on the while statement. Yeah, consist, I did this one. and then DB list tables, we are seeing the tables, then send queries, and then while a statement, it has all those queries, and then now disconnected. Now this is the schema database on the MySQL. And so each times I connect to a different database profile or schema changes. So I'm going to do the schema here, and then information, and now get a list of tables. Now do a send query with the selected statement from tables, limit by 6. You can do limit by this, or group by, or order by. You can do all of that. Now see the list of the tables, and DB clever result, DB disconnect. So the method you do on all of them are the same. Now this one is for SQLite. Do you want to restart our to SQLite? So I'm going to say one or more of the package to update or currently loaded. So I'm going to say, yeah, go ahead, do that one. The default is just doing that installation of the package. Any changes? Now it's going to go to the data empty cars, run that one, and then empty cars, and it's going to print that information, number of rows, and then a number of columns. And here's the datasets output, library MariaDB. This time I'm going to connect to MariaDB for cars db.db. This one, notice the MariaDB, when we do this one, connected, I'm creating like a cars db.db. This one is saying that if this database exists, use it. If it doesn't exist, create it. So I'm going to say run this one, clear screen. Let me just go first for making sure that RSQLite is loaded. So before you connect it, you say library and then RSQLite. So you just load that package first, or the library. You load it, and then now you load it, then you say connection. Could not connect to the database, unable to open database file. So the database file is not found. This one is not finding it, and then I have to create a database file or somehow RSQLite DB file. It's maybe I'm not in the same directory where the SQLite database file is. So I could say get a working directory here. And then now notice that I'm on a different directory here. So in order to make sure that I'm on the right directory, I could set my working directory to the directory where my data file is. So I'm going to go here and say the data file is on this directory, I believe. And then the name of it is carsdb.demo. Carsdb.demo. Okay, I could see it from here, directory store and .db. No, demo programs are let's just say C colon users Wahid and directory of where is that on us? I forgot the location of that file. What I could do is look for it on the on the directory store.db/s, and this would search on anything in my directory, and then I'm going to check for anything with cars. So if this one doesn't find it, I can look it up another way, but usually it is the same place where our programs are. So let me just see demo1.db cars db. So if I say get working directory of this one, see what is this one gonna return me. Okay, this is wrong. I need to be on my directory. Let me just set my working directory, set working directory. I'm going to do that one before this one. Set working directory of c:/user/Wahid. And then I'm not sure if it is on here or not. I could just do this one first. And then get working directory. And let's just set up the directory first to make sure that I'm on that directory, which is there. And then if this one is found in there, yeah, it was found there. So it is on that directory. Let me just see if I go on the command prompt here and say directory store.db and course.db is there. So that's why it the connection found it on that location, because this time I set up after loading the library, the current working directory to be pointing to where the file is. If you don't have this one, you have to force it with this one in front of this. That would also do it if you just did not do this one. So in other words, you could do something like this. And then that would find it, and no matter where it is, because you're telling it where to find it. So even if your directories are not set, which in this case right now we already set, but if you just run this one, this will also find your DB file. So now library MariaDB, we're loading MariaDB, and then at this time, these are the connection for MariaDB. So I'm gonna also go on services here, on the services, and then start MariaDB to make sure that MariaDB is running. So right here, I'm gonna say, I could just say started. I don't have to do it like on the boot. Next time it will not be done. So that is done. Actually, for the MySQL, I'm going to stop it. I don't need to be running that one. I'm sorry. When you want to stop, you basically do this one and say stop. MySQL Workbench, I don't need it. And then I could say change it to manual. So it does not come as the boot. But MariaDB, I started manually. And when I shut down, it will be not at boot time, because it is still MariaDB was also right here as manual, okay? But it's running right now, meaning that I can go to command line, say MariaDB, MariaDB, MySQL client to MariaDB. You can connect it here and type in the password. I'm not sure if I remember correctly, MariaDB 1, 2, 3, 4, 5. Yeah, I'm sorry. Let me just see what was the password for MariaDB. MariaDB 1, 2, 3, 4, 5. So let's see if why did not connect it. MariaDB. Yeah, it's connected. So /status will give me status, and /s will give you the same thing, and then show and databases, and then you can see the database show databases, and then we'll give you the database, and then all that use, for example, demo1, and then show tables. If you have any tables there, you could do use sys, for example, show tables, and so on. I mean, you could do that since I'm connected. I don't need to test that one further. And then the IDE, MySQL is also available, which is a very nice interface here, IDE SQL. last time I showed you, you can also connect it through that and say open it, and then once you connect it, you do same things. Like right here, I did the view of this query. You can run it and then just get output of it. And so, for example, show databases, run that one, you will get the databases, and then describe demo the assist the table. You could get the, if the table exists, that's that one. Demo does not exist because I delete that one afterwards, so it's not there. And then show tables, use assess, and then show tables. You could do exactly everything on those statement. You could do that same thing. All right, so this is the table. So I'm gonna close this one. I don't need to use that one. Close it. No, don't save it. No. Okay, so I'm back here on the MariaDB, and then I'm gonna just these are all commented out. I'm not sure why I commented out. Oh, SQLite. Let me do a SQLite first. For the SQLite, we could run this one, and then yeah, library. Yeah, some of the examples I'm showing is for MariaDB. Some of them was SQLite. Where SQLite, you can connect it through CON and then do a SQLite here, like the actual this, or you could just do something like this with CON, and then I may have the example already, but you could also connect it to a memory base like this, and instead of doing it colon and then memory and then colon. This will just read it from memory, and once you close it, it's gone. But this will write it in the database. So, and depending on which one you want to do, you can do that one. But let me see if with this one, I may have saved it for SQLite here. SQLite. This is for MySQL connection. Select the statement, and then number rows. Most likely, all of my example was for MySQL. I could have just done some of them with MariaDB if I didn't do it, or maybe another session. Let me see. SQLite install the package, empty cars, dataset, empty cars. Oh yeah, so here libraries SQLite. Memory or with MariaDB, MariaDB, DB Connect. So let's do the MariaDB. The SQLite is similar. You could do that one, and right here you could do a memory query. You could send information, connect it, and read it. Most likely I did that one earlier. I'm not sure why I didn't save that one. I don't want to rewrite the whole thing, but you can just do the same thing with everything on the way we did with these other ones. Instead of connecting it, you could connect it like this, and then the rest of them is through these packages of connecting it to either DB MariaDB or SQLite, and then connecting it with a constraint. So since I'm doing it with MariaDB, I'm going to show you that. So let's just do this one. MariaDB, I'm doing it with root, and then password, and then DB. Okay. I'm gonna just say the second one maybe is the one that I want to use, because you could do it one-liner or you could do it with multiple lines. So I'm not sure why I commented out at some point. Maybe we could just check it out. And typeof is connection, classes, the actual connection, and then DB list objects of that connection, DB list. Okay, so this is for connecting to MariaDB. Once you load the MariaDB, you say library, and then it will load it now. And the next thing is to do a connection. So connection is there failed to connect unknown database, MariaDB. So the MariaDB is not understood here as a DB name. And then in MariaDB we had, let me just say, sys. And then I'm gonna try to connect to the sys database. No, it's not seeing it. Finish working with connection, says warning message. So it already closed it as soon as it opens it, 3307. Yeah, I'm connecting to that one instance. So on the MariaDB, show databases and demo one, and then MySQL. Performance schema, information schema. I'm gonna say information schema. Let's connect to that one. Information schema. And then try to connect to that one and run. Now connection is successful because that database exists, that profile exists. So now that connection type is S4. And then we say connection, it says RMariaDB package, DB list objects, you get the list of objects. All of these ones are objects within the Maria database, or the list of it. So then the next thing is that DB list objects and DB list tables, to see the list of tables. This is all the tables that are there on the MariaDB schema database. Files is there, tables is there, so on. All of them is schematic, their users are there. So, and then if I want to do something from it, like with the DB send query and other ones, I could do that one also, using same kind of statement that I did with after the DB connect right here as completed record set. So you could say here all of that information record set. Let me just copy this one to up to I'm not sure, but the MySQL I did this one consists SQL statement is a lot. Send query, number of rows. Right here, record set database send query, select the store from user summary. So if I just do one of them, let's just copy only this portion of my code. Con MySQL. Control C out of this one, and then go back to the last line here. I called it that, but then I'm gonna say, okay, now right here, I'm going to not connect to this one, and the connection is consist. So consist, I'm going to shoot. Okay, and this one, I'm gonna remove this line, DB list table. So I'm having the con, or must this one is I don't need it. And now all I have to do is here, and then let's do a table of whatever was the tables. I'm gonna select the start from tables, just tables, whatever is in the tables table. And then DB has completed record the query, fetch print result, and then do this one. DB con and disconnect this. I'm going to disconnect from con, and then the connection is that. Let's see what other things is. This is also CRAN. The connection that I'm using, record set is the same. Record set, should be that. So now we did this one. I'm gonna list the tables first, and then this is the list of tables. So inside here, my list tables, I should have a table called tables. Users and tables, yeah, we have it. So now I'm gonna do select from tables, and then do a query on it with a while read, and there you go. How simple is that, right? So no matter which a statement you're running is a query string, a SQL statement, and no matter what database you connect, you always connect to it. You pull the record with a cursor or fetching it, and then the record set, and when you're done, you close it, and you are now clearing the record set here and disconnect from the database. Now you're done. Okay. So this was a lot, and I hope this video is going to serve you a very better purpose. And please make sure that you join our channel and subscribe and like our videos, and make some comments and share it with your loved ones. If I didn't catch anything that you needed, just put a note there. And if you appreciate the information that I'm passing on, write a nice note. And I would really be happy with reading that one, that I made some impact on your life. God bless you all. Take care. Have fun. Bye-bye.